Okay, so good morning. I hope I'm audible. My voice
Yes, sir. Yes, sir. Yes, sir. You are audible.
perfect. Okay, so good morning, everyone. This is Dr. Somnath Roy Chaudhary who will be hosting today's session. So I welcome you all on the penultimate day of this wonderful international faculty development program entitled Frontiers in Bioinnovation, Innovations in Bioengineering, and Biopharmaceuticals for Healthcare, Industry, and Sustainability. So we had wonderful 3 days under the leadership of Dr. Gaurav Kumar, Associate Professor and Head of DBB School of Bioscience and Technology, who is on board already, and we are already having Dr. Rahul Jain on board. Hello, sir. Namaste. So, who will be
I
starting
understand.
session. So, I welcome you all in a wonderful monsoon morning. So, monsoon is now at its full spread in Greater Noida, hopefully, and we got some relief from scorching heat. So, before going into the details, I would be privileged to share a few words about Dr. Rahul Jain. So, Dr. Rahul Jain is currently working as a biofuel specialist in Global Biofuel Alliance, New Delhi. Uh, he is an international alliance bringing together 34 countries and 14 international organizations launched under India's G20 leadership in 2023. Dr. Jain holds an industrial PhD from Indian Institute of Technology, Delhi, and an MS in energy from Indian Institute of Technology, Guwahati. He is a recipient of the Prime Minister's Doctoral Research Fellowship for his doctoral research conducted in collaboration with NTPC Limited earlier in his with NTPC Limited. Earlier in his career, he was associated with the Center for Science and Environment, one of the India's leading environmental think tanks. His work has been deeply focused on India's compressed biogas ecosystem, where he has analyzed feedstock potential, policy frameworks, and implementation challenges. Dr. Jain has authored multiple policy reports, contributed to a book chapter on India's CBG landscape, and led the landmark report Greening India's Energy Mix with Compressed Biogas, one of the earliest practical guides for establishing CBG plants in the country. Beyond research, Dr. Jain has played a pioneering role in capacity building and science communication, including designing India's first 3-day residential training program on CBG, organizing national level webinars with government partners, and contributing regularly to Down to Earth magazine. In recognition of his impact, he received the Global Award at the International Biogas Industry Awards 2024 in the United Kingdom. So please join me in welcoming Dr. Rahul Jain on board virtually. Welcome, sir. Welcome to the FDP, and the stage is yours now.
Thank you, Dr. Somanathan. I think I'm very flattered by the warm introduction that you gave about me. And first of all, I would like to congratulate Galgotia University leadership and Dr. Gaurav Kumar, Dr. Nitesh, Dr. Somanath, and the other team members I may be missing for organizing this wonderful faculty development program. I think it's a great initiative, and I'm overwhelmed that about 127 participants have already joined us. And Dr. Gaurav told me that more than 1,000 people joined for this program. So I think, first of all, a big congratulations to all the team members. Uh, Moving further, I think a very good morning from Delhi to all the participants who have joined for this program. So I'll be mostly talking about biofuels here. Please allow me to share my screen, and then maybe I could go forward. Yeah. I hope the screen is visible. I'm making it big screen.
Yes, sir. Yes, sir. It is visible, sir.
Thank you. Uh, So I work as a biofuel specialist at the Global Biofuels Alliance, and I know only biofuel. So I know I'll be talking mostly on this side. And it will be a mix of technology, policy, best practices, and case studies, mostly in Indian context, as well as some global, highlights that I could, pitch through this presentation. The broad overview of my program will be, uh, initially giving you the background about India's energy demand and, where our oil and gas is sourced from, introduction to the CBG or the biogas, how it is produced, what are the different kind of feedstocks which we could utilize, what are the environmental and energy security benefits if we could tap this CBG for natural gas replacement. Then I could move to the global biogas landscape, how it is happening internationally in different parts of the world, like Europe, US, Canada. I mean, they are doing phenomenal job, especially Europe on the biogas. And then I could come down to Indian landscape, how India is doing it, what are the different supportive policies if somebody has to do it in India, what are some best practices. Towards the end, I have kept some of the case studies, for some of the real on-ground projects which are happening in India and abroad as well. So that will give you a sense of how a project operates and what are the benefits that could be generated out of it. And at the last, I'll try to sum up by giving some of the best practices for CBG entrepreneurs or academicians who want to enter, this field. So that's the broad overview of my presentation. Uh, so just to give you an overview of the Global Biofuels Alliance, which I'm part of. So it's a multi-stakeholder alliance that brings together international governments, international organizations, and industries. It was launched back in 2023 by Honorable Prime Minister Shri Narendra Modi ji, and the leadership of different countries, including United States, Brazil, Italy. And presently, about 34 countries and 14 international organizations are, part of the Global Biofuels Alliance. And the objective is to, foster global collaboration for advancement and widespread adoption of biofuels, be it capacity building, be it hand-holding of policymakers in the area of technical support, be it knowledge dissemination by holding workshop, webinars, information sessions like the FDP program that the Galgotia University has organized. So these are the broad objectives of the Global Biofuels Alliance. Also to facilitate trade between different countries and how the biofuels could be promoted and the best practices could be exchanged. So on this slide, you could see some of the international organizations which are part of it. These include the Asian Development Bank, the BioFuture Platform, German Biogas Association, International Council for Aviation, IEA, IEF, IRENA, World Bank, UNIDO, World Biogas Association, and World Liquid Gas Association. So these are some entities which are associated with the alliance and have been supporting, the broader objectives. Coming to the background on India's rising gas and import dependence, uh, you know, it is very clear that India's oil and gas demand is growing very sharply, and it is anticipated that it will triple by 2030 and it will grow significantly by 2050. The total natural gas demand, if I talk presently, is about 195 million metric standard cubic meter per day, which is huge. I mean, it was in 2024, 2025, it is roughly the same, maybe plus minus five. And about 50% of the gas demand is met through LNG imports. So about half of it, 100 MMSCMD of gas, is presently imported in India. And West Asia dominates supply, including countries like Qatar, UAE, Oman, and contributes to about 70% of the LNG imports. And after the Iran US crisis, the Strait of Hormuz was closed. So, I mean, there was a lot of challenge importing this gas through that route. So, what we suggest is biofuels is a solution for this. So, compressed biogas or biomethane. So, I'll use this word interchangeably in my presentation. So, in this part of the world, in India, it's called CBG, which is compressed biogas, whereas in Europe, it's called biomethane. In US, it's called RNG. So the molecule is the same. It's the natural gas produced from the organic waste. So it presents a strong domestic alternative to reduce reliance on imported gas. And as per the International Energy Agency estimates, utilizing just one third of the India's CBG potential could offset entire LNG import. So, I'll come to that. I mean, what are the different feedstocks by which this could be produced? But if we could just tap one third of the India's potential, about 50% of this import could be substituted. So that's the value it brings on the table. So why biofuels make sense for India? First, definitely, as I mentioned, the energy security. It could replace our imports, and it could shield the economy from volatile global prices. Second is the waste management. Uh, so there are different kinds of waste. You look at paddy, straw, municipal solid waste, industrial effluents, wastewater, animal waste. Presently, all of this waste is being wasted, right? We see problems like stubble burning in the northern part of India, especially during the Diwali festival time when it is being harvested, and it produces lot of uh, air pollution problem in the Delhi NCR region. So using biofuels as a solution, this waste could be mitigated and it could be turned into a valuable fuel. Secondly, we generate a huge quantity of municipal solid waste. And about 50% of it is organic waste, which means that it can be degraded by, microorganisms. So you see a lot of landfills around Delhi. It has about three big landfills. Why not channelize it to produce something valuable which could be utilized? Third is industrial effluents. We have a lot of big industries. Uh, we have a lot of sugar industries, and they generate huge quantity of waste. That's called press mud or filter cake. And presently, it is an environmental issue. And though it is being converted into CBG at most of the places, but yes, that's a valuable waste that could be also channelized. Also, you will be amazed to know that India has the highest animal, population in the world, and with that, it generates a huge quantity of animal waste, be it cattle waste, goat waste, uh, the pig waste. All of this waste could be utilized to produce biofuels. Thirdly, there is a climate action agenda associated with biofuels because uh, when you burn biofuels or the life cycle, calculate the life cycle assessment of generating and use utilization of biofuels, the overall GHG emissions are much lesser compared to the fossil fuels that are being utilized, the gasoline and the diesel or the natural gas. So that way, it helps to support our NDC target. NDC is the National Determined Contributions, which are submitted by the Ministry of Environment to the UNFCCC. And according to that, we need to reduce our GDP emissions by 45% by 2030. I know this figure has been revised recently, but yeah, that's a broad message I want to convey. And fourth is the rural development. So if I, as I already mentioned, if agricultural waste can be channelized to produce biofuels, all the stakeholders associated with that, including the farmers, the aggregators, the local entrepreneurs, will benefit because there'll be a biomass supply chain. You need to store that, you need to collect that. So, it produces jobs, it produces uh, a green fuel in the rural area which could be utilized. So that way it helps in the rural development also. So that's why I think biofuels makes a strong case for India, based on these four broad factors. So, so first of all, there are different kinds of biofuels, and I'll be talking only about CPG. There are biofuels like bioethanol, uh, sustainable aviation fuels, biodiesel, biogas, small scale biogas, and the large scale CBG projects. So my presentation will be focused more on the compressed biogas part of it. Uh, so just to give you an overview, we all must have seen, the small scale biogas projects, you know, जिनको हम लोग गोबर प्रोजेक्ट्स बोलते थे पहले, you know, the animal waste produced by the kettle goes in there. It's a small system beneath the earth, and the slurry came out and the comes out, and on the other hand, the gas comes out. So CBG is a much larger and a much modernized form of that biogas project. Uh, the minimum capacity is to produce 2 tons per day of the natural gas uh, in India, and the average size is about 10 tons per day as of now. Uh, so, what is it exactly? So, it is produced by the anaerobic digestion process, by the degradation of organic matter. And anaerobic digestion process is the process where biological organisms, feed on this organic matter in the absence of oxygen. If you look at the table, it will give you a sense of the constituents of the biogas. It majorly consists of methane, which is about 45 to 75%, carbon dioxide, that's 30 to 40%, hydrogen sulfide, nitrogen, oxygen, moisture, and uh, yes, so these are the broad constituents of it. And whereas if you look at the biomethane, that's the purified form of biogas where the carbon dioxide has been removed. It has been less than 4%, and the methane content is increased by 90%. And the process is called purification. And this results in increased calorific value of the fuel, which results in calorific value of about 36 megajoule per meter cube, whereas for biogas it stands at 21 megajoule per meter cube. On the right hand side, you could see that, as I already mentioned, there are different names to it globally, be it compressed biogas or bio-CNG in India. In United States, it's called RNG. In Europe and UK, it's biomethane, and in China, it's bio-natural gas. I hope this concept is clear. Please feel free to ask any questions if you have uh, any doubts up till here. I hope I'm audible, Dr. Gupta, Dr. Gaurav, Dr.
Yes,
Nitesh, if you could please
yes,
confirm.
yes,
Yes.
sir,
Oh,
yes.
thank
Yeah,
you.
you're
Thank
audible.
you. So, coming to the feedstocks, there are broadly 6 feedstocks: animal waste, agri residue, and industrial waste, municipal solid waste, uh, liquid effluent. We generate a huge quantity of wastewater, be it the municipal solid wastewater or the industrial wastewater. That's also could be channelized to produce biomethane. And energy crops, there are crops like Napier grass which are coming up, and they could also be utilized to produce biofuels. Coming to the India's feedstock base, so it has the potential of about 90 billion, meter billion cubic meters equivalent annually, and this potential is 1.2 times the India's current natural gas demand. So we could imagine how big it is, because you know we generate a huge quantity of waste naturally. And if you look at the feedstock mix, about 45% of it comes from the crop residue, which is the paddy straw, wheat straw, maize straw, sugarcane trash, all this, agri residue. 30% from animal waste, 24% from bio waste, which consists of MSW, industrial waste, and wastewater. Uh, So primarily paddy straw, press mud, animal manure are being utilized as of now. So we have about 150 to 200 projects which are presently operating in India. And these are the primary feedstock which are being utilized. So if I look at the regional distribution, state-wise distribution, press mud is majorly found in Uttar Pradesh, Maharashtra, and Karnataka, as these are the sugarcane belts, and we get a lot of sugar production here. So as a result, we have large sugar mills here where this is processed and this waste is generated. Coming to paddy straws, naturally Uttar Pradesh, West Bengal, Andhra Pradesh, Punjab, where the agricultural activities happen. And coming to animal waste, it's Uttar Pradesh, West Bengal, Madhya Pradesh, and Bihar. And municipal waste is widely distributed. I mean, it's in every city. We generate this waste everywhere. And as I mentioned earlier, Napier grass is emerging as an additional feedstock, which is an energy crop. And it could also be grown on marginal lands and could be harvested multiple times in a year. So that makes it a bit relevant, but uh, definitely not on the food land. So this is the broad, schematic of how the anaerobic digestion project looks like. So we have different, on the left hand side, we have different feedstocks. Then there is feedstock supply chain. Then there is the biogas digester where the anaerobic digestion happens. Primarily, there are two products. One is the biogas, which is purified to produce biomethane and the carbon dioxide. And on the second hand, we have the bioslurry. Let me pull out the pointer. Yes. So on the second hand, we have the bioslurry. So it can also be divided into two parts. The liquid part is called the liquid fermented organic manure, and the solid is the solid fermented organic manure. So this is also important because apart from the gas, we are also producing fertilizer in this project. And this biomethane can then be utilized in different components. It can be used for vehicular transportation purpose as a fuel. It could be injected in gas pipelines for household cooking. It can be, used to produce electricity. In Europe, as it's a cold countries, continent, it can be, used primarily to produce heat. It can also be utilized for industrial applications like pharmaceutical industries. And lastly, it could be used to produce biohydrogen as well. So these are the different applications, for biomethane or CBG. So you could, in this slide, you could also see the numbers here. So different feedstocks in different quantities produce 1 ton of biomethane. So for the same quantity of biomethane, about 15 tons of agri residue is required, but about 60 tons of animal waste is required. So it depends a lot on its properties like how much carbon content is there, nitrogen content is there, total solids, volatile solids. So different feedstocks have different conversion efficiencies. So yeah, I've already highlighted the applications in the previous slide. So coming to the global biogas landscape, uh, so the global biogas and biomethane production reached about 50 BCM in 2023, which is about 1% of the global natural gas demand. And about 80% of the biogas globally is used for electricity and heat generation, which is not the case in India because it is primarily being used to produce, the vehicular fuel. And we have about 40 million household digesters, mainly in China, India, Brazil, Southeast Asia, and Africa. About only 20% of the biogas is purified or upgraded to biomethane, mostly injected into gas grids or used as CNG transportation fuel. but it is growing eventually. The world is moving towards biomethane now, then the biogas or biogas to electricity. And as per the IEA estimates, about 80% of the biogas potential lies in emerging economies like the Brazil, India, and China. Uh, and the global demand is projected to rise 30% by 2030, reaching about 59 billion cubic meters annually. So this slide provides a broad overview of the biogas in different countries. As I mentioned earlier, Europe leads the global biogas production, contributing nearly 50% in 2023, with Germany accounting about 40% of the region's output. China produced about 10 BCM of biogas, and they are slowly transitioning from the small scale biogas projects to large scale biogas projects. But it is still at a lower scale compared to Europe. In United States, most of the biogas or the biomethane comes from the landfill gas. So they have this large collecting, what do I say it, uh, pipes in the landfills, and the gas which is generated there is being collected and converted into biomethane. So Amazon Asian economies, except China, contributes about 13% of the global biogas production, with India and Thailand using biogas for waste management and energy security. Brazil is also coming up in a big way, as they already have a big sugarcane industry, and landfills and ethanol byproducts are also the main sources to produce biogas in Brazil. African countries like Ethiopia, Kenya, Rwanda, and South Africa use biogas, small scale biogas primarily for energy access and waste issues. But there is a big scope to grow biogas there as well. On the right hand side, you could see, uh, you know, primarily for which application, uh, you know, biogas is used in different countries or continents. If you see the Europe, it's primarily uses electricity and heat generation. For China, it's for buildings, which means electricity production. In United States, it's for electricity and heat, and for India, it's mostly small scale biogas projects or converting into electricity. Talking about India, we have about uh, 171 functional projects. So apologies, this is a bit older data. I mean, just 2-3 months back. So this must have been updated, and there are about 191, 200 functional projects as of now, and about 300 projects which are in construction, and about 800 to 900 projects which are in different stages of construction. And you could see the graph, the dark green color shows the states which have the maximum number of functional projects. You could clearly see that Uttar Pradesh and Gujarat has the maximum number of projects which are functional or under different phases of construction, followed by Haryana, Maharashtra, and Karnataka, and Tamil Nadu. But there are other states as well which are coming up, with the CBG projects in a big way. So we have different supportive policies for biogas or biomethane in India. I'll be talking briefly about these policies, how it started and how it moved to, about 200 projects as of now, because it's a big journey. These are large commercial projects which takes time, need supportive policies from the center as well as state. So I'll be talking more from the center perspective as well as from the state perspective. I have a slide on that as well. So Satat scheme was the first scheme that was launched back in 2018 by the Ministry of Petroleum and Natural Gas. And by the introduction of this scheme, the conversation of setting up the biogas projects in India actually happened, the large scale biogas projects. And the major incentive provided to the entrepreneurs here was assurance on the gas offtake side, and there were targets that were being set. there was a target to set 5,000 CBG projects in India. However, we are very far from the target as of now, but that was a very ambitious target that was set. Assurance of CBG offtake at a fixed procurement price by the oil and gas marketing companies like IOCL, HPCL, BPCL was introduced. And the minimum procurement price was also fixed. It was, fixed at rupees 46 per kg, and it keeps on revising as of now. And presently, it is indexed to the retail selling price of the CNG in the market. Secondly, there is a national bioenergy program which was launched in 22 by the Ministry of New and Renewable Energy. And this scheme provided the incentives or the subsidy on the plant capex. So as you know, these are large scale projects. About 10 TPD project cost about 70 crores. And, so that's a very rough figure that I gave. But, you know, considering that the ministry MNRE came up with the scheme and provided a financial assistance of about 4 crores for the new CBG project for about 4.8 tons per day capacity project, and for rupees 3 crore for existing projects with the same capacity. And the maximum financial assistance was capped at rupees 10 crore per project for both the cases. Now, the big part of that CBG projects is naturally the gas, and second is the fertilizer that I mentioned. So there was a big challenge that nobody was off taking that fertilizer, and it is produced in a big way in all the projects. And it's a problem for the projects how to sell that in a good way or monetize that. And the farmers were also very reluctant to initially, test these fertilizer at their fields, which makes sense because they have been using urea, DAP for the last 100 years. Why will they eventually, shift to this biogas digestate? So with that in mind, Ministry of Chemicals and Fertilizers introduced a scheme called Market Development Assistance, and the objective is to provide incentive on this fermented organic manure or the digestate to the CBG project owners so that they could, actually upgrade it or market it the right way. So the MDA of about 1500 rupees per ton for this digestate was provided to the CBG producers. So next there was a scheme called the biomass aggregation machinery. Uh, it was introduced back in 2024 by the Ministry of Petroleum and Natural Gas. And the incentive was on the biomass aggregation. So now if you go to some part of Haryana or Punjab or Uttar Pradesh, you could see these large bales which are shown in the figure. It was not the case 5 years back because there was no machinery, there were no CBG projects, there was no utilization of this. It was just burnt. And the collection, making up of this bale, storing it requires sophisticated and advanced machinery, which is costly. And it was a challenge for the farmers to collect it or the CBG entrepreneurs. So with that in mind, MOPNG came up with a scheme to provide incentive on this agricultural collection machinery itself. So the idea was to support initial 100 CBG projects by providing financial assistance to the CBG producers for procurement of this biomass aggregation machinery. And the 50% of the cost was borne by the ministry for this machinery. Coming on the downstream side of it, the gas offtake was also a challenge because it was primarily sold at the CNG stations. Because as these were remotely located, there were no gas pipelines that were near to these projects. So, it was becoming very difficult for the CBG projects to sell their product to the market, the gas especially. Uh, so the government came up with a scheme called DPI, which provides incentive for the pipeline to be connected to the CBG project. So you could see that under key highlights, the financial assistance that was provided for the steel and the MDP pipeline, uh, you know, uh, for connection of the CBG projects to the gas pipeline. So these were broad central level schemes. Just to update you, there is also an ongoing development at the central level, and they are trying to bring all these schemes together and come up with a single scheme so that, you know, uh, the CBG entrepreneurs need not go to different departments or the ministries to get incentives. So it's in under development as of now. So as part of this promotion of these projects, states also came up with their respective bioenergy policies. So one of the states that I would like to highlight is the Uttar Pradesh, because there were the first ones to bring a very ambitious bioenergy policy back in 2022, and they provided incentive apart from the central government that was provided at a state level to these CBG projects. So they provided about 75 lakhs per ton of project, and the maximum capex was 20 CR, which was double the amount than the central scheme amount. I mean the limit part of it. Apart from it, there are schemes from Andhra Pradesh, Madhya Pradesh, Haryana, Gujarat, Bihar, and Rajasthan. And under all these schemes, they are trying to support the CBG projects by providing certain incentives, be it exemption of the transmission cross subsidy charges, be it providing capex subsidy, be it providing, support on the machinery side of it. So all these incentives are being provided to them so that, they do not face major challenges. So this slide talks mostly about best practices for policymakers. I'm not sure if I have the right audience to talk about it, but maybe I could come at this later if the time permits, and mostly go to case studies as of now. Yeah. So I'll talk about mostly 3, 4 projects that I have personally visited, and I could talk about it in a realistic way, and I could tell you what are the benefits and what are the how is the feedstock supply chain there. So the first project that I'll be talking about is the Goa Waste Management Corporation. It's a project based in Goa, in Saligaon area, and it started back in May 2016. So earlier, this project is producing electricity, and recently there have been ongoing development to switch to the biomethane. So there were 3 gas engines, and the daily electricity production was about 1.37 megawatt hours, and the feedstock was the organic part of the municipal solid waste. The daily feedstock requirement is about 150 tons of organic waste, and about 32 megawatt of electricity is produced in a month, of which about 22 megawatt is sent to the grid, is sold to the grid, and the rest 10 megawatt is being used for internal consumption to run this project. So all the electricity which is being used in the project is being, you know, is being internally produced from this biogas project, sorry. And apart from it, the additional one is being sold to the electricity grid. And the digestate which is being produced, about 35 tons, is also being sold at rupees 4 per kg. So I would like to bring certain innovative practices that made this project successful. First of all, the government of Goa demonstrated an unwavering political will by forming a different body called GWMC. It's different from the municipal corporation, and it was entirely headed by the Chief Minister of Goa, and it included high-level bureaucrats as well as you know the technical persons, and there was internal deliberations almost every month on the project, which made it very time bound and go to happen. Secondly, there is a good amount of money which is being paid by the project GWMC to the plant operator for treating 1 ton of waste. So the feedstock is not free of cost. It is being procured, and it's an integrated solid waste management facility. So all the plastic waste, glass waste is also being taken care of apart from the organic waste. So there were consistent information, education, and communication strategies employed by GWMC staff, which led to the waste segregation practices in the nearby region. And the segregation was about 60% in 2016, which in impressively improved to 90% presently. So what I mean here is we see a lot of plastic waste and organic waste in our bins today. They are, not separated as of now. I personally started doing it, but as there is no incentive, as there are no, as the garbage collection guy usually mixes it, so there is no point doing it. But here, because there was a project which was utilizing organic waste differently and inorganic waste differently, there was a complete supply chain there, which resulted in a motivation for households as well to, segregate their waste. So that was an important point there. Uh, Lastly, as I mentioned, there was a plant monitoring committee, consisted of bureaucrats, technical background, and there were regular deliberations, which resulted in, you know, uh, plant efficiency and performance. So these are some of the images that you could see on the screen. Uh, so this is how the waste comes. This is how the conveyor belts are located, and it gets separated, the plastic part from here, and the organic waste goes into these two digesters. This is the digestate which is produced. It is being dried and then packed into uh, you know uh, good sacks to further supply to the fertilizer industry or the organic farms. One of the things that I would like to highlight here is this project is being led by a woman. You could see here. Uh, and this is one of the few projects in India which is, being led by a woman. It's a very large facility, and I was very impressed to see that. Secondly, there is a project in Uttar Pradesh in India. It's operated by Indian Potash Limited, and the capacity is to produce 10 tons per day of CBG. And the feedstock utilized here is the sugar industry waste. It's the press mud or the filter cake that I mentioned. The daily feedstock requirement is about 300 tons, and the gas which is being produced is used as a vehicular fuel. Uh, uh, and the innovative practices here is the solid and liquid waste or the digestate that is produced is enriched further and is being sold or marketed to the farmers. Yeah. So this is the balloon where the biogas is stored. This is the facility, and you could see these cascades. These are big cylinders by which the gas is being transported to the CNG stations. So it is compressed at high pressure, about 250 bars, and then these cascades are being transported to the the nearby fuel retail outlets, and then it is being sold to the customers. So this is one of the interesting projects that's based in Canada. I have not been to this project, but I've studied about this project. It started in 2018, and the biomethane capacity is to produce 2060 meter cube per hour. And the feedstocks are mix of organic waste, industrial waste, and the septic waste. The daily feedstock requirement is huge. It's 120,000 tons per annum. It has three digesters, and it operates in mesophilic range, which means about 37 degrees Celsius, not thermophilic, with an average retention time of about 18 to 23 days. And the 7% of its biogas production to maintain digesters temperatures. uh, 800 meter cube hour of biogas is piped to the ethanol plant, and the rest of the biogas upgraded and injected to the pipeline. So an interesting thing about this project is, so there is an ethanol project located in the same complex, and there is a biogas project located in the same component complex. And the energy which is being utilized for the ethanol project comes from the biogas project itself. So it's a complete integrated biorefinery where there is no wastage, and all the waste is being utilized in a way that the minimum waste is being produced and makes it self-sustainable. Also, one of the interesting thing about this project is this model for water and energy efficiency, and produces the lowest carbon intensity ethanol in Canada. So we have the different carbon intensity numbers to link to different kind of ethanol based on the feedstock and the production process. And because the source of this uh, energy for the ethanol product comes from biomethane, which is a green source, the carbon intensity of the overall ethanol molecule that is being produced is the lowest, which makes it a high selling or the quality selling molecule in the surrounding area. So one of the interesting projects is the project Nesselbach project in Switzerland. It was installed way back in 2018, and the interesting part here is the CO2, which is being neglected in most of the projects, is also being utilized and liquefied in this project. So we have the natural gas, the biomethane, and the digestate, the two products. But apart from it, CO2 also comes out. As it is a biogenic CO2, in Indian projects, it's mostly emitted in the air, also in other parts of the world. But what they did is, I mean, they have gone one step ahead, tracked that CO2 as well, and liquefied it to made it a food grade quality biogenic CO2. So that's one of its kind, and so just wanted to highlight this aspect as well. These are some images. Also, one of the interesting thing for this project is it is completely energy independent because it generates electricity from the solar panels and utilize it to maintain its digester temperatures. Maybe I'll skip this. Yeah. So yeah, maybe I'll talk about some of the best practices for the. I hope we have time. It's already 10:53. Yes. Uh, so let me talk about some of the best practices for the CBG entrepreneurs, and some of based on some of the challenges that they are facing. So if you are a CBG entrepreneur and if you want to set up a project, these are some two to do things that you need to take care. First is the assurance of feedstock supply. The plant should be located in a vicinity of available feedstock, maximum within a 20-kilometer radius. You should map not only one feedstock but multiple feedstock like agri residue, sugar waste, dairy waste, vegetable mandis. All these waste could go together in your digester. So instead of relying on single feedstock, which can sometimes, cannot be dependent on, it is always good to tap multiple feedstocks. Overall availability of feedstock should be at least 2 times the actual plant requirement. So if you require 100 tons, the overall organic waste in the vicinity should be at least 200 tons. And it is always advisable to fix at least 80% of the feedstock supply using long-term agreements. So, and maintain strong engagement with community stakeholders as well. Because in case of agri residue, farmers are the main stakeholders. And if they refuse to supply their straw to you, it does not make sense. So you need to have a strong, connect with them and, help them understand what the project is and how they can be benefited. So all these factors play a major role if the project needs to be successful. Secondly, the project marketability infrastructure needs to be mapped. You need to see the number of CNG stations nearby. You need to understand the availability of gas distribution grid. You know, if there are any industries which require CNG as a fuel, are there any organic or private gardens or fertilizer companies which are, keen to take this fertilizer? All these things are very important. I'll give you an example of a project in India. I mean, it's based on Punjab. It's based on paddy straw. It is one of the big projects in India, but it is not able to sell its gas. I mean, 50% of the gas, because there is no offtake of the gas in the surrounding area. There are only 3, 4 CNG stations which they are already supplying to. There is no gas grid nearby. It's about 70, 80 kilometers away, which does not make sense to transport from the plant to about 100 kilometers away. And there are no industries. So naturally, this results in a failure. So uh, it is always good to map this offtake infrastructure from the projects. Thirdly, technical and non-technical points. Uh, Availability of land for feedstock storage is also important, because there is a very narrow window of about 30, 40 days in which you will go to the farm when the harvesting happens and, you know, take your feedstock for the next 11 months. You need to have a land to store that feedstock. So that is also important. Sometimes we neglect it, right? Uh, Real-time monitoring of meteorological conditions is also important. Solid road access should be there for the feedstock and the digested movement. Uh, Solar panels is always best for your energy independence. And it is always go to the states where there are already bioenergy policies. So that makes the regulatory approvals much faster. For example, I mentioned about few states earlier like UP, Andhra, MP. So if you go to these states, it will be a hassle-free compared to states where there are no, incentives for this bioenergy. So yeah, I mean, I would also like to bring up, a program that was launched by the Global Biofuels Alliance few months back. It's called the Global Biofuel Champion Fellowship. So my presentation ends there, but I will, just tell you about that, because I feel there are a lot of faculty members which are joined from different parts of the world and India, and it is very important uh, uh, to know about this program, because it's a new program and the objective is to create next generation of leaders which are capable of thinking real world biofuel challenges, solving real world biofuel challenges. And it's a program, 1 year program, and the objective is to bridge the gap between the academic research, the industrial relevance, and the policymakers. So that's the broader objective. And the eligibility is existing masters and PhD students, which are registered in any institutes of the world, are eligible to apply. And their area should be biofuels. And we support up to 15 fellows per year. Over and above the regular fellowship that they get, we provide 15,000 US dollars per fellow, which is about 14, 15 lakhs. And this amount can be utilized for their research work for presentation at conferences, for some exchange programs to procure chemicals. So we have a list of that as well. And we have, apart from the financial support, we have a list of global mentors and juries who are associated with us, and they will be helping those fellows. Uh, as well as we, from the Global Biofuels Alliance as well, we will be mentoring those fellows regularly, and they'll also serve as the GB ambassadors over the next 2 years. Just to give you a glimpse of the jury committee members, we have professors from University of Sheffield, University of Sao Paulo, Brazil, Imperial College London, IIT Madras, and Germany. And mentors from these 8 institutes, from Turin, Best, IIT Guwahati, University of Kentucky, University of Leeds, UK, University of British Columbia, Canada, Stellenbosch University in South Africa, and IIT Delhi. So these are some of the respected biofuel professors or experts which are associated with us. So with this, I would like to thank and up for any questions if you have, and feel free to reach me at the mentioned email address or contact number. Uh, so the deadline for the fellowship program for this year has already been closed. For the next year, it will open in December, and uh, the interested applicants can apply from December to January most likely, and the program will start from June to July. Will run from June to July. Thank you.
Okay. Thank you, Dr. Jain, for this wonderful presentation on the trajectory, the global trajectory, so to say, about this biofuel research. So the house is now open for question answers. Participants are requested. I mean, I could see a question that came from, yeah, anyway, like, I think it's like, I'm not getting the question, but I could see one question. So maybe the participant can unmute yourselves and feel free to ask questions regarding the talk. I could find one question from Dr. Geeta Bhagwat from DY Patil University. Dr. Bhagwat, are you on board? Maybe you can come back on the question, or maybe I can read out for you. I don't see her on board now, but maybe I can read out the question. So she asked, I have read that cattle generate methane and nitrous oxide in flatulence. So how to take care of the gases released by cattle? So that was her question.
Yeah, so I believe this is what I gave the presentation on. The you mean the cattle waste or the cattle itself? If
Dr.
you if
Bhagwat,
what
are you there? I mean, she has only mentioned, I have read that cattle generate methane and nitrous oxide in flatulence. So how to take care? That's what her
Yeah,
question
so
is.
that's altogether a different problem. So there are, if I talk about kettle, so they have a natural process to generate methane, right? And on the other side, they generate waste that's called kettle dung, right? So my focus is on primarily mitigating that waste to produce biofuels. It's not on the biomethane or the methane that they produce, it's on the waste that they produce. But I know there are ways to mitigate that methane as well. There are some diet changes which are being done, which results in less methane production from from the gut of the kettle. I know of a startup which uses algae as a feedstock, microalgae as a feedstock. It is being tested in Europe and in West Asia. And cattle is being supplemented in their feed with some specific kind of algae, which results in less methane production. But that's a different topic to talk about.
I think Dr. Bhagwat wants to follow up.
Hello,
Dr.
yeah.
Bhagwat,
Can
are
you
you
hear
there?
me
Yeah,
now?
yeah.
Okay. Yeah, I was not able. I mean, you had not unmuted me. Yeah, correct, sir. I have gone through your presentation. It was very nice, and it was, I know, about the waste and the biofuel. But my question was slightly different, and I think you have answered it well because you said that algae in the feed of the cattle will help them reduce the amount of flatulence, and thus it will again help reduce the amount of methane and nitrous gas, which are problem matters to be released in the air. So I was more concerned about the environment.
Right,
So I
right.
think I got my answer. This is one way which you have suggested that algae in the field. So I was
Yes,
trying to
yes.
find out some other ways also. That is why I
Yeah.
asked you. Thank you very much. Thank you for your answer.
Thank you, Dr. Geeta. Dr. Swaminathan, if you are speaking something, I am sorry you are on
Sorry.
mute.
Yeah, sorry. Apologies. Yeah, yeah. I see a question in the chat box coming from Dr. Nitesh Kumar Singh. The question reads, how can artificial intelligence, IoT, and digital monitoring optimize the operation and maintenance of biogas plants? Dr.
Yeah, so
Singh?
that's a very valuable question, I would say, because artificial intelligence is part of our day-to-day lives now, and biofuels is no separate thing for from AI. I mean, if you look at these projects, there are different kind of sensors which are being so let me divide it into three parts: the upstream part, the midstream part, and the downstream part. On the upstream side, when there is a feedstock collection, you need to know uh, when to harvest it, how to collect it, and how to store it. And weather plays a very important role there. So if you can utilize AI to predict a good weather to harvest, store, and bale, or uh, make that supply chain valuable, that will be great. Also, there is a startup called Biofuel Circle, not a startup but an established company which is being running, which is using AI for the biomass supply chain. So if you are a project owner and if you want to, you know, take biomass, you just go to that platform, fill up your feedstock requirement, and they will use all their models to connect with the farmers and get back to you with the relevant feedstock. That's one way. On the midstream side, I think all these digesters need a regular monitoring because these are biological organisms which are working inside the digester. Uh, so the factors like pH, nitrogen, total solids, all these factors need to be monitored on a regular basis. Uh, so the relevance of digital monitoring and artificial intelligence also goes there. So in case there are uh, growing number of microorganisms and less production, or the other way around, the AI can maybe optimize which human intervention requires certain time and can, nullify or can optimize to make it more efficient at that moment itself at the midstream level. At the downstream level, I see there is a lot of scope for marketing improvement of the digestate that is being produced. Because if using AI, if the digestate could be upgraded or any useful components could be derived from it, and it can be marketed in the right way, uh, and the farmers could be convinced, nothing like that. So these are some avenues that I'm just thinking out loud. Do not know the right answer to it, but yes, these are some ways which I think uh, digitalization and AI could be integrated.
Dr. Nitesh, would you like to follow up on the question?
No,
Okay.
sir. Thank you.
Okay, fine. So,
Thank you, Dr.
uh,
Rahul Jain, sir.
so any other questions coming from the participants? I mean, I see a lot of appreciation messages. Okay, then maybe it's my turn. I have two quick questions, Dr.
Sure.
Jain. One will be like regarding this generation of biogas. So what we need, so we need to have a supply of biomass for sure to convert for this. So considering this heavy metal contamination in India's this like whenever you are trying to get some biomass and converting it to fuel. So do you think this can be an additional problem to tackle the heavy metals absorbed in the form of bagasse or all whatever heavy, I mean the biomass are being utilized these days to convert it to biogas? Or what would be your
Yeah, I mean,
take
that's
on
an
it?
excellent question, Dr. Somanath. I think in terms of the production, I would say natural gas will be unaffected by it because it is mostly the organic part which is broken down by the microorganisms, not the metals or the inorganic part.
Hmm.
But definitely in the digestate or the fertilizer that is being produced, there will be contamination of metals, which will make it difficult for farmers to utilize it. So that way, uh, it is a challenge.
Hmm. Because and another, I mean, I have a different question. I mean, I was once associated with a similar kind of project, like in my master's in IIT. So where we were trying to convert this, I mean, low rank coal, that is lignite. We have a huge lignite in India. So we were trying to convert this low rank coal to biogas and some other value addition. So what do you think? So can, like, say for example, if we have a huge amount of lignite deposited in, not in the upper surface of the earth, so to say, but in the very, I mean, if we can plan for some kind of in situ biogasification of the lignite reserve, what we have in India, so can that be a kind of addition for sustainable development? I mean, what would be your take if we are putting this by, I mean, all these methanogens in, like say for example, some meters depth of this lignite mines, and we try to harvest methane from there directly.
To be very frank, I don't think microorganisms will be best suitable to degrade the lignite coal, uh,
Mm-hmm.
because because I don't think it will take some time. It has a different structure. Uh, if you compare it with the biomass that I'm talking about, it's very loosely bound, right? And it has a good moisture content as well. But if you go to lignite, its structure is a bit different. The
Different, yeah.
molecules are,
Really, yeah. Mm.
yes, and there is very less moisture content as well. So anaerobic digestion using lignite seems to be difficult, but gasification on the other side makes sense. You know,
Mm.
I know of a program which is being recently launched uh, by the central ministry where they are trying to, utilize the low quality coal present in India for gasification,
Mm.
uh, to produce, I believe, the end objective is to produce green hydrogen, I believe, if I'm not
Okay,
wrong.
okay, okay,
Yes. Yeah.
okay.
So that's one of the programs, but uh, I'm not
But
sure
that
if
is, I
it will
mean,
work with
like,
anaerobic
okay, so that
digestion.
is like, I mean, a microbial conversion from those
No,
biomass
that's
to
that's a thermochemical conversion. That's a
thermochemical.
thermochemical.
Okay, yeah,
Yes.
yeah,
So
okay.
high temperatures conversion without
Ah,
absence of
okay,
oxygen. Yeah.
okay, okay. Yeah, thank you, Dr. Jain. It was a wonderful
Yeah.
lecture. So I don't see any more questions coming. The chat box looks to be empty. Okay, then thank you, Dr. Rahul Jain, for this wonderful talk. So
You are most
please
welcome.
join me in, and I mean, presenting a virtual memento to Dr. Jain. Just a second, let me share my screen. Yeah. So thank you once again, sir, for your wonderful presentation. And on behalf of the organizing committee, I once again acknowledge your wonderful presentation, and please accept our uh, token of
Thank you
appreciation.
very much. It was a real delight to be among this pool of relevant experts and present here. So it's a real pleasure to be here. Look forward to connect with you physically as well in the near future.
Yeah,
Thank you very
yeah,
much.
for sure, for sure. Yeah.
Yeah,
Thank you,
yeah.
Dr. J. Thank you.
All
Yeah.
the best for the next I mean half, or I think it will be ending this Friday, right?
Yeah, tomorrow. So we are on the
Yes.
penultimate day today, so we have one more day. So it was a very wonderful session. So enlightening talks, packed up
Thank
with
you.
wonderful. to be
Thank you
yours.
very much.
Thank you so much. Okay,
Real pleasure to be here. Thank you. Bye-bye.
bye. Okay, so now we move on further with our next speaker. Uh, just give me 1 minute for the transition. Let me welcome Dr. Ekta Srivastav. Ma'am, are you on board? Dr. Ekta Srivastav, ma'am. Dr. Srivastav is already on board. I can see her name. Ma'am, I have made you co-host. Can you kindly respond?
Sir, can you also?
Yeah, ma'am, your audio
Okay,
system is
sir,
making echo. Yeah,
am I
hello.
audible?
Yeah, you are audible. Your system, yeah, now it looks better. Okay, so
Am I
we have,
audible?
yeah, you are audible, ma'am. Is it fine for you to switch on
Yeah,
the
okay, sir. There
camera?
is another, like, can you make Ekta Srivastav that as the host?
I think I have made already. Just give me
There is
a
another
second.
ID that is Ekta Srivastav.
Acha, another ID. Okay, okay, okay. I have made like Dr. Ekta Shaja. You have another login? Okay, then let me find out.
Yes, yes, sir. Just for the sake of like,
Okay, okay, just a second. Is it Acha? You have your photo, I guess, here. Yeah, okay. I found you.
yeah.
Yeah, I think it's done now. Your both profiles are now co-host.
Okay, so am I audible?
Yeah, you are audible, ma'am.
Actually, that's only for the better connectivity because it's raining. Like,
Yeah, yeah, here is
there
also
might
the.
be a possibility that there is a power cut or something. So that is why I have logged in through two different IDs.
All right, no issue. So, ma'am, is it fine for you to like switch on the camera from any
Yeah,
of
yeah,
the login
yes,
IDs so that I can get you introduced to the audience? Okay.
yes.
Yeah, so we have Dr. Ekta Srivastav already on board. So welcome, ma'am, to the faculty development program. So we have been having wonderful 4 day, I mean, a 5 day program. So we are on the 4th day now. So before I hand over the stage to Dr. Srivastav, please let me introduce Dr. Srivastav in front of the audience. So Dr. Ekta Srivastav is currently working as an assistant professor in MNNIT Allahabad in the Department of Biotechnology. She earned her PhD in Biological Sciences and Bioengineering from the Indian Institute of Technology, Kanpur, where her research focused on the development of electrically conductive smart biomaterials for nerve regeneration and the study of nerve bone crosstalk. Her research interests include biomaterials, tissue engineering, regenerative medicine, drug delivery systems, stem cell engineering, polymer conjugation, and electrically conductive biomaterials. Dr. Srivastav has published extensively in leading international journals and holds 3 Indian patents, including 2 granted patents with strong translational potential. Her research excellence has been recognized through prestigious awards, including the SERB International Travel Grant, National Bio-Entrepreneurship Competition, that is NBEC Award, Mahi Young Scientist Award, and the Young Women Innovator Award. She continues to advance innovative biomaterial-based technologies aimed at developing next-generation regenerative therapies and clinically relevant healthcare solutions. So, ma'am, welcome to the Faculty Development Program. On behalf of the organizing committee, I extend our acknowledgement for accepting the invitation. So, the stage is yours.
Thank you so much for the kind invitation, and also for the introduction. Shall I share my screen?
Yeah, perfect. Good to go.
Is it visible now?
Not yet. Yeah, now it's fine. You need to put it on the full screen mode. Yeah,
Is it visible?
yeah, it's fine now.
So I would like to thank again the organizing committee for the warm and kind invitation as well as introduction. I welcome you all to my talk titled Fabricating Advanced Electroceutical as Next Generation Smart Scaffold. So in my talk, I will be discussing the significance of electrically conductive materials for the regeneration of the bone as well as nerve, and how the regeneration of the nerve can assist in the bone regeneration as well. That is the bone nerve crosstalk. So starting with a small introduction about the nervous system. The human nervous system, as we know, is divided into 2 parts, the central and the peripheral nervous system. Further, the central nervous system comprises of brain and spinal cord, whereas the peripheral nervous system is coming out from the spinal cord, and further it runs throughout the body. Now, if we look into the structure of a particular peripheral nerve, we can see that it is further wrapped with epineurium. Inside epineurium, there are many fascicular bundles, as we can see, that is wrapped again with perineurium. Now, if I take out one bundle, I can see that there are number of nerve fibers that are present, and these nerve fibers are further enwrapped in endoneurium. Taking out one particular fiber, I can see that it is composed of axon and further is wrapped by the Schwann cells. Now, if we look into the structure of the axon, it is comprising of, or the neuron, it is comprising of dendrites, cell body, and axon. Now, this whole axon, cell body, and dendrites further form the structural and functional unit of the nervous system, which is a neuron. Now, information from one neuron to the other is taking place with the help of synapses. Now, as the impulse is traveling through one neuron, it releases neurotransmitters that can be excitatory or inhibitory. Now, these bind to the receptors present on the postsynaptic neuron, and accordingly, the transmission or the inhibition of the stimulus takes place from one neuron to the other. Now, the function of the nervous system are divided into 3 types: sensory, motor, and autonomic. Sensory functions are perception of pain and temperature, touch, proprioception. Motor functions are management of the reflexes and the pattern movement of the limbs, whereas there are many sympathetic and parasympathetic functions that are managed by the nervous system. Therefore, as the nervous system is controlling the major functionality of an organism, any sort of an injury, whether due to traumatic, infectious, or congenital lesions, leads to drastic consequences, and depending upon both the level of the injury, that is, if the central nervous system is damaged or the peripheral nervous system, and the severity, that is it a compression injury, that a mild compression of the nerve has taken place, or is it a complete transaction injury
I guess Dr. Ekta has lost her connection. Hello, ma'am, are you there? So let's wait for Dr. Srivastava for a while. I mean, she was telling that there will be some network issues today.
So can I like start again?
Yeah, please, ma'am. I think I need to make you host again. Anna, you are already added as co-host.
So am I audible?
Yeah, you are audible, ma'am.
So can I start again?
Yeah, you can start from where you had finished. From there, we can move further.
Yeah, from where I have left. Yeah.
Yeah, yeah.
So is my screen visible?
Uh, Not yet, but it has started to be shared. Yeah, now it's visible, ma'am.
Okay, okay. I'm extremely sorry like for this
I mean, yeah, but these
interruption, but I
technical
knew that it
glitches
would
do have
happen.
nothing. Yeah, yeah. No, we can understand. Yeah, no issue. Please move on.
So, depending upon the type of injury, whether it is traumatic, infectious, or congenital, as well as the level of the injury, whether the central nervous system or the peripheral nervous system is injured, and also the severity, that is, whether it is a compression injury or a transaction injury, transaction in a way that the nerve is completely disconnected from both the ends. The symptoms may vary from numbness to paralysis. Most often, most of these neural injuries are accompanied with neuropathic pain. The treatment approaches right now in clinics are medication surgery, and this is accompanied with physiotherapy, whereas there are few emerging approaches like tissue engineering, stem cell therapy, and neuromodulation. Now, I'll be focusing my talk more on tissue engineering. So, tissue engineering is an interdisciplinary field that applies the principle of engineering and life sciences towards the development of biological substitutes that restore, maintain, or improve the tissue function. Now, there are different kinds of scaffolds that are being designed to regenerate the nerve, and this is nerve wrap and nerve conduit. Now, most often these wraps and conduits are often conjugated with cellular systems, biochemical factors, topographical cues, and electrical cues. So, if we go through that, what actually is the lacuna in the field that still exists? It's like that there are many publications that show the significance of electrically conductive scaffold and electrical stimulation for the regeneration of the nerve. But there was no such report that are actually coupling electrical stimulation and the electrically conductive scaffold. So, basically this lacuna may be existing because if you put electrically conducting material to the scaffold, it at times compromises the biocompatibility of the scaffold, and also there is a lot of parameters optimization like the doses and the frequency of administration, because you already have an electrically conducting material that is present at the site of implantation. So the stimulation that needs to be given requires a much more optimization as compared to giving the two treatments but singularly. So, working on this, our hypothesis was that if we design a combinatorial therapy where an electrically active scaffold with biochemical cues is given, but this is also being coupled to electrical stimulation intraoperatively, so that during the implantation we are also giving electrical stimulation, it might enhance the nerve regeneration and also the functional recovery. So when I was working on this hypothesis, I have designed like three different kinds of scaffold for three different critical problems. That is electroband as the first objective. Now this is a nerve wrap, or you can say a bandage kind of a structure for the nerve, and we have depicted its clinical efficacy in the peripheral median nerve injury model in rats. Now, the second objective is fabrication of reduced graphene oxide substituted nanohydroxyapatite to reconcile the nerve bone crosstalk, where we have seen that if there is a bone injury, now if nerve at intra-bony nerves are also getting damaged. So, in any case, if we could regenerate the nerve and we can check the effect if the bone is also repairing simultaneously, what is the effect if the nerves are stabilized? Its effect on the bone repair as well. And as a third objective, we have designed electrically active cryogels for the spinal trauma to treat a paralysis kind of a condition. In all three objectives, what we have done is we have also given electrical stimulation during the implantation of the scaffold just to see if there is some sustained regenerative response from the scaffold. So coming on to my first objective, now as we have seen that there is multiple layers inside the nerve that is present, like from epineurum, perineurum. So there are also different levels of injury. So the first level is neuropraxia, in which just there is mild compression of the nerve and the nerves are not yet damaged completely. Axonotmesis, in which axonotmesis level 2 is basically when the axon is damaged. Axonotmesis level 3 is when the endoneurium is also damaged. Now, axonotmesis level 4 is when the perineurium is also damaged. So, as we increase the level, the severity or the damage is also increased right from axon to perineurium. Now, neurotmesis is the case in which the epineurium is also completely disrupted. Now, because the body also has some regenerative response towards any sort of an injury that is taking place, the same is true for the peripheral nerve injury as well. So, the peripheral nerves also get, once they get damaged, the Schwann cells, they become reparative cells. So, they start dividing and they form these basal laminal tubes kind of structure. Now, what happens is that till the time Schwann cells are actually upholding their regenerative potency, if the axon could regenerate and reach the basal laminal tube, there is regeneration that is taking place. But in case the Schwann cell, the axon, or there is a critical gap of like more than 8 mm or 10 mm, then the axons are not able to reach the Schwann cell tubes in time. And what happens is that there is a prominent gap, and the basal laminal tubes that that Schwann cells actually form, they start deteriorating. And this is the case when there is a chronic problem in the muscles, and therefore the muscles, because there is no neuromuscular junctions, there is no functionality in the muscle also starts to atrophy. For this, what we have designed is we have conjugated topographical, electrical, and biochemical cues and designed a wrap for the nerve, that is electroband. Now, electrospinning is the technique that we utilize to design this, and chitosan gelatin and reduced graphene oxide were the polymers that we used. Coming on to the results, this is a SEM micrograph of the chitosan gelatin nerve wrap, and this is after we have mixed the graphene, reduced graphene oxide in the wrap. The reduced graphene oxide actually induces the electrical conductivity. Now, in the AFM images, we can also see that there are reduced graphene oxide flakes that are present on the surface of the nanofibers, and also the reduced graphene oxide enhanced the electrical conductivity when we measured it through the Ford probe analysis. We further also studied the biocompatibility of this scaffold by culturing neuro 2A cells. Now we can see that the cellular adhesion as well as the proliferation is increased after mixing reduced graphene oxide, and the SEM micrograph or the live dead staining, they depicted the healthy morphology of the cells over the surface of the scaffold. The same was also confirmed with the DAPI staining. Now, after these biocompatibility as well as the physiochemical properties of the scaffold, we moved ahead with an animal model where we have studied the median nerve injury model. Now, median nerve, it actually innervates the forearm and hand flexor muscles of the forearm, and it assists in the movement of forearm, wrist, hand, and fingers. So, this is how with the help of median nerve performing its function. And this is the median nerve pathology where the nerve is affected and the grasping power of the hand actually goes. So one of the most common pathology that is associated with the median nerve is the carpal tunnel syndrome. In this case, there is this tunnel that is formed which median nerve passes. The tunnel is formed by the tendons and the arrangement of the carpal bones of the wrist. Now, in case this narrow passage sometimes decreases in diameter due to extensive usage or compression, and therefore this leads to compression of the median nerve as well, and the patient actually experiences numbness in these areas and is not able to exert the force. So what we have done is we have tried to mimic this carpal tunnel syndrome by targeting the median nerve in the rats. Now this is healthy median nerve. This is the nerve after compression. We have compressed it for a period of 30 seconds. This is a transected nerve. We have also targeted the transaction nerve model. This is the electroband that is wrapped around the transected as well as compressed nerve. Now, this is the material, image of the material. This is further clubbed with electrical stimulation. So the groups were that compression and transaction only were the negative controls. We have provided only electrical stimulation and only wrap as well to check the effect of single therapies. Now we started clubbing the wrap with the electrical stimulation, that what is the effect if we provide wrap with the stimulation. And our last group was the combinatorial group, where we have given NGF, that is nerve growth factor, as the biochemical cue along with electrical stimulation and the wrap. So we can see that this is a healthy animal. The healthy animal actually uses both its limbs to perform any function. Now this is the rat condition, and you can see that the animal would not be able to use its hand on the is performed. Further, this rat perform any function, the animal was not able to use it to perform, and this was the loss in the functionality of that particular limb. We assess the functionality of the nerve by performing electrophysiological assays. Further, behaviorally by performing paw gripping experiment and scratch tape assay. Anatomically by NF200 and S100 immunostaining. And further, we checked if the functionality of the muscle is restored or not after the nerve regeneration by performing mesenteric staining and also taking the weight of the muscle, because the loss in the functionality leads to atrophy of the muscles and the weight is drastically reduced. Coming on to the results, this is how the electrophysiology was performed. There is a difference electrode. Then we have a stimulating electrode and a recording electrode. The recording electrode actually measures the compound muscle action potential of the muscles after we stimulate that particular nerve with the help of a stimulating electrode. Now this is the paw gripping experiment where the animal was allowed to rest on a cage and then it was inverted. Now if the animal want to resist itself from falling, it has to exert tremendous amount of force, and we could measure if there is regain in the functionality. Then we moved on to a more extensive experiment where there was a tape that was wrapped around the healthy hand, and the animal uses its other hand to scratch that particular tape. Now, if the animal is able to regain its functionality, the animal would be able to regain that particular, would be able to take out that particular tape. These are the results. So almost in all the experiments that we performed, we could see that combinatorial group, of course, is performing much better to individual group. Even in the group where we have provided wrap with stimulation, was able to perform well as compared to where we were giving only scaffold and only electrical stimulation. The same was the case with the transaction group as well, where we can see that the combinatorial group was performing way better as compared to individual approaches. Now, this is staining images, and interestingly, we can see that because of loss in functionality, the negative, the nerve has started to degenerate, whereas exuberant growth of the nerve fibers can be seen in the animals with combinatorial therapy. Again, we have the staining of the Schwann cells that show if the degenerated nerve is actually being myelinated by the Schwann cells also. And we can see that there was active myelination that was performed in case of the animals with combinatorial group as compared to the negative control. This is the immunohistological analysis of the transaction group. And interestingly, what we can see is that there is this bright color structure that was present in the negative control. Now, this structure somewhere marks the formation of neuroma, that is uh, erroneous connections that would not lead to regain in the functionality, whereas there is good growth of the nerve fibers that can be seen in the animals with combinatorial group. Now, because negative control has got this neuroma structure, there would not be proper transmission of impulses, and this would lead to atrophy of the target cells. And the same was seen when we performed mesenteric staining, where we can see that the muscles have severely atrophied in case of negative control, whereas healthy muscle morphology can be seen in the animals with the combinatorial therapy after the compression as well as transaction injury. So we also assess these recovery by performing different videos, and we can see that at day 7, due to lack in vegan and motor functionality, the animal is not able to hold the cage and would fall off very easily. Whereas the same animal, when we were assessing at day 56, the negative control, due to very limited regeneration and regeneration being not completed, though the animal was able to hold itself on the cage, you could see that the animal is only able to do it with the two digits of its hand and not completely hold the cage. Whereas the animals with the combinatorial therapy, we can see that there is complete regain in the sensory and motor functionality. The animal is able to hold itself onto the cage for a much longer duration of time, and with its all digits being intact. Then we moved ahead with a more strenuous exercise of scratch type essay, and we can see that in case of negative control, the animal was not able to exert any force by its hand, and was only holding the other hand closer to the mouth, so that now the animal is able to scratch that particular tip. Whereas the animal with the combinatorial group, we can see that the animal is able to scratch that tape, and most importantly is able to exert the force on that particular tape that is assisting it in scratching that tape out. Now, this is only possible because of the proper regeneration as well as storage of the sensory and motor functionality. So this brings me to the conclusion of the first study, that we have fabricated a clinically relevant electroband as the nerve grab. We also demonstrated the efficacy of giving electrical stimulation when it is clubbed to scaffold implantation. We have designed a combinatorial therapy and we have shown its efficacy, and also we show that that a proper nerve regeneration is important for forming correct neuromuscular synapse formation. Coming on to my second objective, now we have designed electrically conductive nanohydroxyapatite, that is a bone substitute, to study the bone nerve crosstalk. So we know that diabetes has slowly become a pandemic for the current population, and is a disease when the blood glucose level is of course abruptly high. Now it is of two types, 1 and 2, where the immune system destroys the beta cells, and type 2 when the cells are not able to use the insulin that is being produced by the body. Now, most of the vital organs of the body are affected. For example, there is nephropathy, there is diabetic foot ulcers. Now, you have retinopathy, where there is peripheral artery disease. But one of the underlying aspects is a diabetes associated osteopathy. Now we know that bone is divided into two types, that is compact and the cancellous tissue, and there are four different kind of cells: osteogenic cells, osteoblasts, osteocytes, and osteoclasts, that make the bone. But one interesting feature is that there is an extensive network of nerves and blood vessels that is also running throughout the bone. Now, because of the hyperglycemic condition and nerves being in close proximity of the blood vessels, there is drastic effect of the hyperglycemia on the nerves as well. So this nerve and the blood vessels or the bone cells are in a crosstalk kind of environment, where there is this bilateral conversation that is taking place from the peripheral nerve to the bone cells, as well as from the bone cells to the peripheral nerves in the form of neurotransmitters, peptides, mechanical, electrical, and biochemical cues. Therefore, this sustained increased glucose level actually leads to oxidative stress, microvascular changes, adipogenesis, osteogenesis imbalance, and deposition of the advanced glycation end products in the bone. Now, this deteriorates the quality of the bone, leading to fragility fracture. There are many different treatment approaches, anabolic and anti-resorptive therapy. Because nerves being in the close proximity is not yet dragged that amount of attention, is that there is also underlying neuropathy with the osteopathy that is taking place simultaneously. So we asked a few questions that if there can be a therapy that is targeting not just osteopathy but also neuropathy, and can there be a connecting link that could rejuvenate this bone nerve crosstalk, and also if the therapy could not only work in like normal conditions but also hyperglycemic conditions or diabetic patients. Now, to answer these questions, we came across that electrical cues could act as an interface between the bone and the nerve. And for this, we have designed electrically conductive bone substitute. So basically, the hypothesis was that if we have electrically conductive bone substitute, when we are implanting it, we are also providing electrical stimulation. Now, being a bone substitute, it would enhance or augment the bone recovery. And being electrically conducting in nature, we can also have an enhanced nerve recovery as well. First, we have synthesized indigenously reduced graphene oxide substituted HAP. Now, in our lab, we already had HAP powder being made, that is hydroxyapatite. What we have done is that we have mixed graphene oxide in the solution of calcium nitrate tetrahydride and diammonium hydrogen phosphate. What we get is graphene oxide substituted HAP. Now, after sintering it at higher temperature, this graphene oxide get reduced to reduced graphene oxide, and this reduction is important to enhance the electrical conductivity of the bone substitute. Now, because we have electrically conductive nature, we measured it with the AFM, and we could see that the surface potential drastically dropped from 25 to 15 and further to negative values after mixing reduced graphene oxide. Now, this shows that the mixing of the reduced graphene oxide has led to increase in the electrical conductivity. So we further had formed cryogels in which we have mixed chitin gelatin reduced graphene oxide, freezed it, which led to formation of ice crystal, and further lyophilized it, that is freeze dried, so that now the ice crystals are vaporized. What we get is a macroporous cryogel structure. We further have characterized this cryogel with SEM micrographs, and we could see that there was still porosity that was there. And this mixing of reduced graphene oxide has resulted in increased electrical conductivity, due to which this, as we can see, this would result in the lightening of that particular body. We have further examined the biocompatibility of these scaffolds by culturing bone marrow derived mesenchymal stem cells, and we could see that there was enhanced in proliferation as well as functionality of the scaffold. The SEM micrograph depict the cellular morphology, and the alizarin staining depicts the calcium deposition by the maturing mesenchymal stem cells. Further, we have moved ahead with an in vivo injury model where we have drilled a hole at the greater trochanteric region of the femur bone, and then we have further taken it, extended it longitudinally so that we can get a fracture model. This was further filled by our own designed substitute. And because we are studying the nerve bone crosstalk, we have somewhere compressed sciatic nerve. Now, this would also mimic the trauma condition of a patient that who is damaging its femur bone, because that often leads to also crushing of the adjacent sciatic nerve. So these were the groups where we had defect. Then we had substitution of the non-conductive HAP, the conductive HAP, And finally, a combinatorial group where the conductive half is also being coupled with stimulation and biochemical cues. So the functional recovery we have assessed by performing electrophysiology as well as performing DEXA scans and microcity analysis. Now the DEXA scan show that in case of negative control, we can see this prominent fracture that is present, whereas this was completely mineralized because of enhanced cellular infiltration and maturation of the cells in case of animals with the combinatorial therapy. We further have assessed this by performing different staining. Now, this is HNE staining that again shows the fractured condition, whereas this is completely filled up in case of animals with combinatorial therapy. The same is depicted with mesenteric staining and collagen type 1. We could see that this is the initiation site of the defect and this is the fracture site. The fracture site was completely filled up in the animals with the combinatorial therapy. Next, we have the immunostaining images of the nerve. Because we have also crushed the nerve, we also wanted to check whether it's only the bone parameters, but also the nerve parameters that have improved. And we could see the distorted morphology of the nerve fibers in case of animals with the with the negative control. Whereas animals with the combinatorial therapy, we could see healthy nerve fiber morphology, whether it was NF200 that depicts the nerve fibers or S100 staining that depicts the Schwann cells. So because of the distorted morphology of the nerves in case of negative control, we can see that the muscle fibers have started to degenerate, whereas healthy muscle morphology can be seen in the animals with the combinatorial therapy. We have also assessed this with the help of video recording of the animals on the treadmill. At day 14, there was no group who was willing to walk on the treadmill, although they were already trained to walk on that. Even if the animal was put with the prominent fracture and no recovery by day 14, none of the animals were able to walk on the treadmill. Now, when we assess the same animals at day 56, we could see due to recovering the parameters where an electrically conducting traffic is present, the animal was able to walk on the treadmill. And therefore, because of the maximum recovery in case of animals with combinatorial therapy, we could see that that particular animal is able to keep a pace with the moving belt. And this is because of the complete repair of the fracture and also regain in the functionality of the nerve fibers. This brings me to the conclusion that we have fabricated an electrically conducting bone substitute and have depicted its enhanced effect on not only just the in vitro cell cultures, but also in a hip fragility fracture model in the rats that were diabetic. So the incorporation of electrical stimulation enhanced the nerve recovery as well as the bone parameters. Coming on to my final objective, that we have fabricated an electrically conducting aligned cryogels for the spinal trauma. This is the spinal cord. It is present in the vertebral canal that has been formed the adjacent placement of the vertebra. Difficult to operate for any surgeon. If we cut it transversely, we can see that it is composed of gray matter and white matter. And there is this very complex network of nerves that is running longitudinally throughout the entire length of the cord. Any sort of an injury to this structure, whether it is complete, that there is a complete injury to the cord, or incomplete, where there is just minor compression or minor damage to the cord, but there is still some transmission of information that can take place. Both these kind of injuries leads to paralysis, either tetraplegia, where both the limbs are affected, or paraplegia, in which mostly the lower limbs are affected. Now, there are different phases of spinal cord injury as well. That is first the acute, that is marked by cellular infiltration of the immune cells as well as the resident cells of the nervous system. Subacute phase, during which the astrocytes actually become reactive astrocytes, and they start surrounding the lesion pore. Now they do this so that the other spare tissue remains protected. Now the last phase is the chronic phase, in which there is formation of mature glial scar that is further filled by a fluid-filled cyst cavity. So to treat this kind of an injury, where there is this scar that gets formed and it inhibits the regeneration of the nerves, we have designed electrically conducting cryogels. To provide electrical stimulation, we have used transcranial mode of electrical stimulation and used neuroprotective agent, that is epithelon B. The methodology to design these alignment was to have unidirectional freezing with the help of liquid nitrogen. Now, because this liquid nitrogen would come out longitudinally, the polymer solution is freezed in the presence of liquid nitrogen, and what we get is an aligned porous structure as it is depicted in the SEM micrograph. Now, this is the random porous structure, whereas this shows the unidirectionally freezed cryogels with longitudinal pores. Further, we have examined its biocompatibility by culturing the spinal cord on the surface of the scaffold, and we could see that there was cellular infiltration from the explant towards the surface of the scaffold, depicting its biocompatibility. We further have checked the nerve fibers growth over the surface of the scaffold by NF200, and you could see that this is the explant and the nerve fibers could actually adhere to the scaffold wall and grow in particular longitudinal direction that is required for the regeneration of the spinal cord. Now, to depict its clinical efficacy, we have performed spinal cord injury on rats. Now, this is the T9 vertebra. We have performed laminectomy, in which the laminar region of the vertebra is cut and taken out. This will provide access to the cord, and this is the white region is the spinal cord. This is how the compression injury was done. We have used blunt forceps for the compression injury, and further we have also performed transaction injury, in which we have taken the one gauge needle, and with the help of needle, the spinal cord is transected. Now, this is how the scaffold is placed at the surface of the cord. So this is the scaffold, the black structure, and we have further placed it at a place of compression or transected cord. So we can see the condition of the animal after we have performed the surgery. Now, because of the compression, the animal is not able to use its hind limb and is paraplegic. Now, in case of transaction, the animal is even more severe. For transaction injury, we actually transacted and the animal was completely immobile in the cage. These are the groups where we have negative control, we have electrically conductive material with stimulation. Now, as a chemical factor, we have utilized drug that was given intraperitoneally. That is the route through which the drug is given. And also, we have further designed the combinatorial therapy, in which we have loaded the drug onto the scaffold, clubbed it with the stimulation, and healthy animals were taken as the positive control. How we have assessed the functionality, that we have performed the staining of the spinal cord. Now, if the spinal cord regenerates, it would lead to improvement in the functionality of the sciatic nerve. So that particular nerve has also been assessed, examined with immunostaining. We have also performed immunostaining at the gastrocnemius muscle level by performing Mason's trichome staining. And lastly, we have performed the behavioral assay, that is the paw gripping experiment. For all these assays, we have longitudinally dissected the cord, not transversely, as well as the nerve fibers also has been cut out longitudinally to check the arrangement of the nerve fibers. This is the staining image, where we can see that in case of negative control in the compression injury, there is a prominent cyst that is present. The cyst is completely surrounded by astrocytes, as can be seen in the GFAP staining. Now we can see the good growth of the nerve fibers, aligned growth of the nerve fibers in the animals with combinatorial therapy. And these nerve fibers are also surrounded by the astrocytes, as can be seen with the GFAP immunostaining. Now, because of the prominent cavity in the cord, the functionality of the sciatic nerve has also been damaged, and therefore there is distorted morphology of the nerve can be seen, whereas healthy nerve fiber morphology can be seen in the animals where we have given the combinatorial therapy. and the same can be seen with S100 immunostaining. Now, because of the presence of cavity in the cord and distortion of the nerve fibers, the dystrophy of the muscles can be seen in case of negative control, whereas healthy muscle fiber morphology can be seen in the animals with the combinatorial therapy. Next, if we see NF200 staining of the spinal cord where we have transected the cord, we can see that again there is prominent cavity that is present. Again, it is surrounded by the reactive astrocytes. In case of combinatorial therapy, interestingly, what we can see that there is like regeneration of the nerve fibers from the proximal to the distal end of the defect, and interestingly this oblique trajectory has been followed that was formed during the surgery. Now there is close proximity of the astrocytes that can be seen with the regenerating nerve fibers, and this shows the important role of the astrocytes, that if given appropriate cues, the astrocytes not hampers the regeneration of the nerve fibers, but it actually enhances the nerve fiber regeneration. Now again, because of the prominent cavity, there is nerve fiber distortion that is taking place, and because of the regeneration, the preserved or healthy morphology of the nerve fibers is seen in the animals with combinatorial. Because the animals are paralyzed, we can see that there is complete distortion of the muscle fibers as depicted by the mesenteric staining, whereas healthy muscle morphology can be seen in the animals with the combinatorial therapy. Now there can be some damage to the nerve fibers that still can be seen here, and this is because the animals after the transaction and injury were completely paralyzed, and due to which there is some distortion that has already taken place by the time the spinal cord could regenerate. This was again assessed by performing video recording of the paw gripping experiment. Now we could see that the healthy animal is able to grip the cage completely and is able to roam in the cage, roam about on the cage. Basically, is able to exert the force on the cage. Whereas the animals with negative control completely jumps off, and this is because there is no regain in the sensory and motor functionality. Animals with a combinatorial with the electrical stimulation is able to hold the cage, but as soon as we invert the cage, it is difficult for that particular animal to perform, to exert any force. Whereas the animal of combinatorial therapy, you can see, is able to hold the cage and is able to also exert some force. But still, the maturation takes some time. We kept the animal for a period of 4 weeks. There is maturation of the new connections that will be required to hold on to the cage for a longer duration of time as compared to the healthy control. So we successfully demonstrate the therapeutic efficacy of the aligned cryogels in the spinal cord injury model in that. And this shows that there is efficacy in the combinatorial therapy to treat paralysis kind of a condition. We also see that the scaffold could reduce the lesion cavity, and it also helps in protection of this bad tissue. So basically my work somewhere shows the significance of graphene as the regenerative electroceutical, where not only as the nerve wrap, but we have used electrical stimulation to regenerate the nerve bone crosstalk, and also used electrically conductive scaffold and electrical stimulation as organotronic to regenerate the spinal cord kind of tissue where regeneration is extremely limited. So we are now working on developing advanced electroceuticals where we are working on designing drug conjugated dots. Now these dots would further be coupled to smart scaffolds that would be stimuli responsive, that could work on certain stimulus like pH, temperature, oxidative stress or electrical stimulation, so that we develop something that is patient specific delivery platform. There is a real-time feedback control in the system. So this is just a graphical representation of what we are doing now. We are synthesizing different quantum dots, the scaffold, and further coupling it to the scaffold. Now this would help in designing personalized medicine. So we have some feedback or the real-time control of the amount of drug that is getting released, and it becomes patient specific. So, coming on to the acknowledgement, I'd like to thank IIT Kanpur and my supervisor, Professor Ashok Kumar, for all the assistance that he has given me during my research period at IIT Kanpur. Further, I would like to acknowledge my current working place, that is MNNIT, Director Professor R.S. Verma, HOD Professor Manisha Sachan, and all my colleagues and faculties at the Department of Biotechnology. Thank you.
Thank you very much, ma'am, for this wonderful presentation across multiple, regarding these biomaterials and this applied field, like how it can be utilized for human welfare. So now I open the house for discussion. So participants, you may kindly drop your questions. You can raise your hands virtually. The house is now open for discussion. There are some appreciation messages I can see in the chat box. Let me quickly go through the chat box, but I don't see, I guess, any question for the time being. Okay, so if there are no questions, then I thank you once again, Dr. Srivastav, for wonderful presentation and accepting our invitation to be a speaker in this faculty development program. So please join me to present our token of appreciation to Dr. Srivastav. Just a second. Let me share my screen. Sorry. Somehow this screen is not sharing. Maybe some technical issues I find. Let me switch. Yeah, now it looks fine. So thank you, ma'am. Please accept
Thank
our token of appreciation on behalf of this organizing committee of this International
Yeah, I
Faculty
also
Development
thank like
Program.
Gaurav sir, and I also thank Rupita ma'am and Gaurav sir for the opportunity, like, and also the entire department and institute for giving me this opportunity to like speak and discuss my work. Thank you.
Okay, ma'am. Thank you so much. So we are done with the first half of today's faculty development program. So it's time for a lunch break. So we will be having three more speakers for three exciting talks in the second half of this session today. So participants are requested to reconvene at 1:30 p.m. as per the normal schedule. And we will be having three more speakers in the second half of the day. So meanwhile, you can enjoy your lunch and we see you again at 1:30 p.m. Thank you. Uh, Hello, Pankhuri ma'am, are you there?
Hi, good afternoon. Can you hear me?
Yeah, I can hear you. Okay, so yeah, we will start within 5 minutes. I'm just waiting for
Sure.
some participants to join. Yeah, okay. Okay, so good afternoon all for, the second session of the fourth day of the faculty development program. So we now have three speakers on board. So let me welcome Dr. Pankhuri Narula. Ma'am, are you there?
Can you hear me?
Yeah, it's fine now. Yeah, good to go. So I hope all the participants are now with a full level of energy after having their lunch break. So we will be moving on further with our faculty development program. So before I hand over the stage to Pankhuri ma'am, let me have a quick introduction. So now the next speaker is Dr. Pankhuri Narula. She is a DBT biocare scientist at the Indian Institute of Technology, Delhi, where she is engaged in cutting-edge research on the structural mechanisms of virus disassembly using cryo-electron microscopy. She completed her PhD from the Kusuma School of Biological Sciences, IIT Delhi, specializing in peptide therapeutics. Her research interests span structural biology, virology, peptide therapeutics, and antiviral drug design, with a focus on deciphering the molecular architecture and dynamic behavior of viruses to facilitate the development of next generation antiviral therapies. By leveraging advanced cryo-electron microscopy techniques and interdisciplinary approaches, Dr. Narula aims to bridge fundamental biological discoveries with translational healthcare applications. An emerging researcher in the field of structural biology, Dr. Narula is committed to advancing scientific innovation through collaborative research, mentorship, and knowledge dissemination, inspiring the next generation of scientists in biomedical and life sciences. So please join me in welcoming Dr. Pankhuri Narula. So ma'am, welcome. So now the stage
Thank
is
you.
yours. You can start sharing your screen and we are
Okay, so
eager
is
to
it
hear
visible?
from you. Yeah, it's starting, I guess. Yeah, you can
The
put it in
PPT
the
is
full
visible,
screen
right?
mode. Yeah. PPT is visible now.
Okay, so
I think you can
thank
put
you
it in
so
the full
much, Dr.
screen mode. Yeah.
Somnath and Dr. Gaurav and Dr. Anjali for giving me this stage where I can, showcase what I'm doing in my field and share some interesting insights that we have got in this domain. So I'll just give you a brief, he has done a very elaborative introduction of mine, but I'll just tell you what I'm working on right now. So in my current project, I am structurally elucidating uh, you know, the disassembly intermediates, specifically of the non-enveloped viruses. So coming to this title has a story behind it that I'll also be discussing, how we reached where what I'm doing right now. So it all started when I finished my PhD and I was looking for the postdocs, and I got an opportunity to work in an industry academia collaboration, which was between the Unilever and the IIT Delhi. So the task given to me was to, check the effect of their formulations on a specific group of viruses, that's the non-enveloped viruses. So it was given to me, and I thought it is, the start of it, I thought like it's how it's going to be because it's like the purification and everything, and it's the non-enveloped viruses. And to me, it was stated very clearly, like, you have to see this effect in a matter of 1 minute. So I remember that ad of Unilever. I hope if you can remember where they say ki 99.9% kitanu khatam, right? So I was kind of working on that thing. So I'll just take you throughout my journey of my postdoc, and I'll tell you how it began and how sometimes the biology, the sciences take you from where you have started and, make paths for you where you are, I'm doing right now, the work. To start with, I'll just give you a brief. I think I'll just on a laser right now. Pointer. Okay. So the brief introduction. We all know viruses are classified into enveloped and the non-enveloped ones. And envelope, as the name suggests, they have this lipid in nature envelope around them, which is followed by the proteinaceous capsid. And enclosed within is the genome, which can be DNA or the RNA. On the other hand, I was given the task to handle the non-enveloped viruses. As the name suggests, they lack the outer lipid envelope, but they have a very strong resistant protein layer, that is the capsid, which encloses their genetic material. And due to this absence of this envelope, they are also known as the naked viruses. And this absence makes them very resistant to a variety of antivirals strategies that are there, in the scenario. Whenever we are, processing with any kind of diseased study, so we need to have a model system for that. For this, by default, the model system that we chose was the feline Kelsey virus. Now you will ask me, felines is not related to the humans. So how are we going to, act upon it? So feline Kelsey virus is very much related and to the human noroviruses. And the human noroviruses in recent times also, you must have heard, they are the notorious ones which cause the gastroenteritis, and they have caused epidemics all around the world. And feline calicivirus and human noroviruses share all the physical and the chemical properties. And human noroviruses are not, they are very difficult to propagate in the cell culture system. So that is why the model system for the human noroviruses are the feline. They are very small, 30 to 35 nanometer in diameter, RNA viruses, and they're highly resistant to the disinfectants and the sanitizer. They're very basic in structure. So they compose of two major proteins. So if I'll talk about the green one is the VP1, which is the major protein. And these two are the VP2, which is present in very low amount. So VP1 is further divided into the shell domain, P1 and P2. What I'm explaining right now of the shell and P1 and P2, I'll discuss more about it in the following slides. And the other virus that we took is the adenovirus. It is comparatively very large, around 100 nanometers. As we all know, it is the main causative agent of the respiratory illness that goes in the hospitals majorly for the kids, the children, and the ones which are elderly and the immunocompromised. So whenever they are suffering from some severe respiratory illness, so adenovirus is the main culprit behind it. It's a little more complex. It has a variety of proteins. And its level of resistance is somehow moderate, not as fierce as the calicivirus. Then the goal that was given to me was to identify the hand sanitizer formulation which were effective against the non-enveloped viruses. So whenever you are given you have this hypothesis, so you do a study design. And so starting with, I needed to have a model virus cultures and their purification strategies, because for this kind of a study, we really wanted the viruses to be at their utmost purified state. We cannot have any kind of a contam around it, because we really wanted to see and design something which were acting against those viruses only, without any kind of indulgence from other noises. So once this was done, then we had to study the effect of the formulations which was provided by them and designed by them. And they also made a very, this point, like if this shows an effect, we really want to go underneath and see how it is acting, which was very, comprehensive from their side. Like they want to know how their formulation is acting. They don't want to stop you showing the effect or not. So that was another task which was given to us. So we went to the literature and we saw if there's anything that works like this and how these studies are generally done. So they say that when some kind of antiviral is acting, it either acts when the virus is inside the cell or just before the entry. That means it is somehow doing some structural alteration. So which is, not letting it uh, complete its life cycle, or at first stage, the attachment at the entry level. So we thought these kind of a virucidal agent that they have provided may lead to the premature disassembly by causing there's a loss of the viral capsid component. That is the structural alteration. So we went ahead with these thoughts and strategies in our mind. And the toolbox was first is the establishment of the cell culture, because we needed a large number of viruses, infection, propagation, purification, and identification. So for the identification, we chose two major techniques. One is the differential scanning calorimetry. This is an amazing, thermal analysis technique, which tells you about if there's any kind of a structural alteration, if there's any kind of a change in the molecule. So it tells you about it in the terms of it gives you this change in terms of a peak at that specific temperature. So DSC has been long known to mimic the disassembly phenomena that is actually happening inside the cell with the virus. So we took DSC to see if we can catch any structural alteration in terms of mimicking it to the receptor binding. And once it goes inside after the attachment, there is any alteration when there is a release of the nucleic acid. Third one we employed because we really wanted to see this, since we were anticipating the structure is going to change. So really wanted to see, and seeing is believing, right? So we employed this transmission electron microscope to morphologically characterize and to visualize the changes that are happening. So with this in hand and everything set, we went for the methodology. So methodologies, we had the virus log, both ADV and FCV. We did the primary infection. For ADV, we chose the HeLa cells, and for the FCV, we chose the CAT cells, kidney cells. And we infected the cells, and then we had to look for the cytopathic effect. So it was different in both the cases. I'll tell you in coming slides, right? So once the infection, we saw the cytopathic effect, we collected the cells and the soup. And now we did the secondary infection where we employed a large number of cells because we wanted the virus to be purified in a good amount, right? So we had to go into a large number of T75s and T175s. So once this was established, we saw the cytotoxicity, and then we took the supernatant and the lysate. We went ahead with the density gradient centrifugation. Here we choose the cesium chloride-based ultracentrifugation, and if you have crossed all these hurdles of cell culture and establishing a good ultracentrifugation, if you're fortunate enough, you might see your virus settling down at a specific pace in your gradient according to its density. If your culture and everything is very pure, you see a very discrete, distinctive band here, like you can see here, which gives you an idea like you are lucky enough to get the virus. This band was then taken and then was employed for the TEM and the DSC. And once we were sure we had the purified virus in hand, we moved ahead with the treatment and the characterization. So I'll start with the AD. So we infected the HeLa cells. So the cells were around 80% confident, and we saw that we checked the infection like after every 6 hours, right? So we saw there was a complete, I would not say complete. So there was around 90% cell death after the 48 hours. So at this time point, like I told you, we collected the soup and the supernatants and we did the ultracentrifugation. This is the band which depicts the virus. Collected carefully this amount of the band, and we did the morphological characterization, and in this we could see very distinctive icosahedral adenovirus particles, which were around 85 nanometers, and they had the definite shape and everything. Once we had this, it was a very happy moment for us. And now the next we wanted to establish this thermal profile. This was new to us, like we didn't know what we are getting, how many changes it's going to undergo, right? So here there is a very incremental temperature raise during this whole process. So like during this, so these are the peaks, this is the pattern that is specific to the adenovirus we got. This small peak may show us, it depicts us that there has been a little change that is happening in the capsid around 4950. Then there was one, you can say a little more major change than the one that is happening around 50, which is at 68, followed by 71. And then there was a big prominent change. So this we anticipated is the complete rupture. But these small changes, they point us towards something is happening in the structure. Maybe there is some loss of the, components from the capsid, which is giving us this peak. But for this study, we had these two things in hand, right? We had the morphological characterization of the intact ADV, and we had the thermal profile, how the intact, the wildlife adenovirus will. Next step was to, treat it with the formulation, which composed of 3.2% citric acid, 1% urea, and 70% ethanol pH4. So we mixed our purified virus in 1:1 ratio, and we incubated for 60 seconds, and then we moved ahead with again these two strategies because we wanted to compare it with the wild type. And if you look here, the inactivation. So this is the intact one, as we can say, it's the profile. But when we are treating it with the formulation, you see there is some changes in the structure, which has led to the aggregation of the virus particles. And they are clumped together. They are not maintaining their icosahedral shape. They are, disintegrated. There have been points of opening in the capsid. And when we went for the DSC, so this is very interesting. We saw that the first peak, which we were seeing at around 49, has shifted to the 45. So this means the treatment of the virus particle with the formulation has somehow make it a little unstable, that all these things are happening at earlier time point rather than the ones which are happening in the intent. So all major temperatures shifted to the earlier ones, indicating the formulation has led to the instability into the study. And we also wanted to check what if we treat them with just 70% ethanol. And in 70% ethanol, again, we can see there's a clumping and aggregation, but at some points we were also able to see, intact pump. And in the DSC profile of this, there was just one peak, major peak around 50, which indicates that the majority of the particles have lost their components and they have kind of disintegrated. So from this, we can, say like each component of the formulation, it's 70% ethanol and everything, they affects differently to the stability of the adenovirus. And when they are combined together, synergistic action is taken place on the particle stability, as it is evident from both TEM and DSC. And the formulation, of course, treating leads to the premature disassembly. As we can see, there's a shift in the temperatures, which may point out towards the release of the capsid components, which prevents the ultimate infectivity. So if I'll talk about the FCV, the same thing we did, like we infected the CRFK cells, and for this, the cytopathic effect was seen after 16 hours, as you can see here. And then we moved ahead with the ultra, the cesium chloride ultracentrifugation. Here we got a very turbulent, but just remember this picture. I'll show you what we did to, make it more pure. We collected the band, we did it the ultra, we stored at 4 degree and did the TEM and the DSC characterization. And if you can see here, we were able to see the beautiful FCV particles. They are very distinctive in their shape, like a flower, they have this small cups around. So Kelly's means cups. So they are very distinctive in morphology, and we were able to see all this, very at different magnifications, and they were around 37 nanometer in diameter. And then after this morphological characterization, we wanted to move ahead for establishing its DSC profile. And here we observed 3 major peaks. First one at the 56, second at 62, and the third one showing at 8. Again, for this also, we had this morphological evidence and the DSC profile for the wild types. So we move ahead with the same strategy of mixing them together in 1:1 ratio for 60 seconds and did the TEM and DSC again. Here, when we treated it with the formulation, we could see all of the particles, more than 90% of them are gone. They do not have any kind of a definite shape now. They are completely disintegrated. And the DSC profile also showed us the same. It showed a broad peak in the range of 55 to 65, which showed there has been a lot of change that is happening in this range, which has led to the ultimate disintegration of these particles. And if I'll just do the comparative analysis, you see here, this is the intact one. This is the complete damage. There is no individual peaks, as we see here also. But when we treated it with only 70% ethanol, I told you like offers quite a good resistance towards this disinfectants. So we were able to see, good intact particles too. That is why we got a one major peak followed by this small pattern. So if we talk about till now, so for this FCV, the intact ones, I told you it's about 35 nanometer. There are 3 major transitions. Formulation completely damaged them. There was a broad transition peak. 70% ethanol led to the semi-damaged particles, and we were able to see quite a small number of particles in the background, which were T1 insulin. So all this pointed towards the fact like the formulation completely altered the disassembly pathway of the FCV. It completely ruptured the particles within the 1 minute's time. And however, 70% ethanol partially ruptured the particles. And when combined together, they provided a synergistic action, and it was complete formulation in the end, which was more effective. But if I'll talk here, you see, although these both are the non-enveloped viruses and they behave very differently in their mechanism of inactivation. So for adenoviruses, it is the loss of the crucial components of the capsids, which are, important for the initial attachment and the internalization into the host cells. However, if I talk about the FCV, it was the complete collapse of the Philin virus. And they also gave a different DSC profile. So I worked with the Unilever ended here, and then we published a paper on this. But this gave me few leads about here. So this told us like these are the two graphs. These graphs made us curious, and we really wanted to see what is happening at these individual temperatures structurally, what is lost and what the virus still retains, and what if there are these components that are losing, like is it the process of disassembly, like is it the you can see this is how it happens. There's maybe it's the metastable or particular components from a particular side are lost first. And so I wrote a project based on my findings and based on what I want to do further. So I wrote it to DBT and it got accepted, and that is why I'm working as a DBT Biocare Fellow now. So I took these as my base, and then since we want to structurally characterize it, so there came into picture the cryo-electron microscope. And the process that we were targeting here is the disassembly process. So what is a disassembly process? So after, in fact, during the receptor attachment only, there is a trigger which leads to the alteration in the virus capsid. That is, it makes some components loose. After the internalizations, once the virus is inside the cell, so there is a uncoating mechanism. Uncoating is very crucial so that the nucleic acid can exit and go into the replication and translation mechanism and leads to the generation of the new viral assemblies. So we are trying to catch it here, which is very dynamic. It is very transient. But if somehow this uncoating is stopped or altered, or somehow the virus is not able to uncoat, so the life cycle will stop here and the virus infection will also get stopped. So this is a very crucial step in the virus life cycle for the infection establishment. And I was kind of a very difficult task to catch it in this stage because it's highly dynamic. So the methodology involved, we had the intact virus, and then we heated it to those particular temperatures of the DSC, like I told you, right? That is the triggering of the disassembly process. And then we are catching it here. We don't know what are we getting. Either the genome is all lost, either it's the point is just nearing the exit point. But we really didn't know what is going to happen. So we tried to catch it at different temperatures and then do the cryo-electron microscopy followed by the 3D reconstruction, identify all the structural alteration. Right? So here I just would like to give you a glimpse of electron microscopy. So as you all know, why electron microscopy? It is the accelerated beam of electrons so that we can have, better resolution. And microscopy is just magnified image of objects which are too small to be seen by the naked eye. And if I talk about the scale, naked eye scale is around 100 microns. And then with the light microscope, it's just bacteria, 1 micron. But if you want to go lower than that, the viruses and everything, you really need to have the electron microscope. And there are two major types, that is the SEM and the TEM. So SEM is the surface, as it tells you by the name, it's a scanning. And it majorly tells you about the surface of the particle. And if you really need to know what is kind of an inside of a particle, you need to go for the TEM, that is the transition electron microscope. So here we use the transition electron microscope, but we really need to understand the structural precision that is at the near atomic resolution. So we had to go for the cryo-electron microscope. So cryo-electron microscope is all about visualizing life at atomic level. So this is the video. The students said they'll just get a glimpse of how things work in just 1 or 1.5 minutes. Oops, did I do something? This is the point of this assembly. Yeah, this video, I mean, kind of summarized what I was talking about and how, at what stage we can try to control it. So these are some of the snippets where the cryo-electron microscopy has been used all around, like for the nucleosomes, for the wire structures, and also for the channel proteins. So I'll show you some of my work where we have employed it in the following slides. So this going back to cryo-electron microscopy history, it all started in 1970s with the basic of them. And then there were, since we are dealing with the biological materials, they are very sensitive. So 1980s, there came the concept of vitrification, where it's a rapid freezing of your sample without the formation of a crystalline ice, so that the native structure of your sample is not destroyed somehow. But then there are a lot of challenges in terms of technicalities based on electrons as a source, and then a lot of processing of the micrographs that you have got. So all these years with combination of working in the biology side, in the physical and the technical sides, and making better softwares to process your data. So all this year went by, and it was finally in 2018-20. So the Nobel Prize was awarded to this particular technique. So there was, like I was telling you, the challenges of specimen hydration. So there came the cryogenic temperature, use of the cryogenic temperatures, and then there was crystallized formation where they introduced the concept of vitrification, that's the rapid freezing of your sample. So all these were, challenges that they were encountering, and they were step by step they were solved, and now we're at a time point where we have structures at near atomic level, and we can clearly see the atoms and everything, how they're changing, and everything which are important for us to design a drug or a vaccine, and to understand the basic mechanism of virus life cycle. So these are the breakthroughs, and there's a concept, the cryo-electron microscope, if you read about, which is called the resolution revolution. So initially, they used to say the concept of electron microscopy as blobology. Like what you see is just like a blob. You can't see anything very definite. So all these breakthroughs came like vitrification, cryogenic temperatures, improved electron optics, DEDs, and the software, which are the single particle analysis software and the automation. So all these breakthroughs came. There was resolution revolution, and the term globology was then changed. So from this graphic, you can understand how the the images used to look, the structure used to look at the initial levels, that is at 79 strong. But with all those breakthroughs, now we are finally at something which is around 2 angstrom, where we can easily see the sheets and the amino acids and everything that are important in one way or the other. Understand whether it's life cycle, whether it's disease progression, whether it's designing an antiviral strategy. So this whole scenario from here to here, we are here now. So it was taken well care of by a lot of people, and this led to the award of 2017 Nobel Prize in Chemistry. Okay, so this video tells us about this process of vitrification, which is very important when you're dealing with the sample prep, right? So this is a video which tells you everything happens in the presence of the liquid nitrogen. So it happens in an instrument called Vitrobot. So you have this apparatus, and you need to be very sure of maintaining the cryo uh, temperatures around. This is very important for you to make sure your sample is preserved, is frozen in a near native state. If anything happens at this point, the sample is gone and you'll not be able to visualize anything. The step is called the vitrification. These are the grid boxes. I'll tell you what grids are. This is the tweezer, which is used to hold your grids. And the apparatus is called the Vitrobot. Just see how rapid it needs to be. Although this is all automated, but earlier people used to do it manually. So this is the chamber which maintains the humidity and the temperature. So they are putting up the sample here onto the grid. Goes in like microliters, around 3 to 4 microliters. It goes up. Test sample is plotted. There are filter papers around. So this time period lets your sample to get absorbed onto the grid. So then excess is plotted, and then this is the rapid freezing that happens. It's called the plunging. The whole process is called the vitrification. So now you have your grid into the ethane pot, which you can transfer into your grid boxes, and your sample prep is done. So we have a different stages here. Yes, at this point, your sample is ready. Sorry. So I'll just move here. Sample purification, followed by the glow discharge. Application we saw, blotting we saw, and the plant freezing. So, when you put your samples, it can be, since you're uh, at this step, the sample purification step, you need to make sure that your biochemistry and your bench work is well taken care of. It needs to be homogeneous. It needs to be in good concentration. There, you should get rid of all if there are any kind of noises in your sample. So this is an ultra important step. 3, moving to the cryo thing. And once your samples are on the grids, we do the imaging. I'll tell you how these images look. And when we have the images, we do the processing, and then we can do the model. I'll take you step by step to that. So we started with the FCV. Remember, I told you my FCV prep initial slides. So we worked on it a lot. We did a lot of troubleshooting, and I told you we need a lot of viruses for this. So we went from seeing few particles to our micrographs filled with the FCV particles. So we started from here, and we took our first temperature, which is 56. We incrementally heated the particles in the DSC in the same instrument. And then when we did the negative stain, you could see, although the particles have maintained their morphology, but there are some kind of a central dark spots, you see? So this stain permeable center, it denotes some kind of a gaps that something has been lost from this particular point, which has led to the openings, and which is ultimately led to the, deep penetration of the stain. That is why they're appearing black. So if you'll compare the FCV intact to that of heated to 56, you can very well see there has been changes in the morphology, although they are maintaining their intact shape. Some of them are ruptured as well, as we can see here, and there's also decrease in concentration, which was well expected in terms we are heating it, right? We took this, we did put them on the grid, we followed the same protocol for the cryo, and this is the cryo micrograph image of the intact feline calicivirus, and this one is of the heated one, the intermediate, we say it now. We collected these micrographs, and we did. So how it happens? So these particles can be placed in any order. They can be upside down, they can show sideways. So there are different orientations that are present. So what we do, there are two basic softwares, the Relion and the Cryospark. For this, we use the Cryospark. So the 2D classes gives you an idea in what all orientations, or in what all are different classes of particles that you have got. So we got around these different classes. So it segregates, every class has some number of particles. So we got around 30,000 particles, and these 2D classes were made. After that, we did the model refinement, and in this, I'll just bring you two concepts. So here it is written icosahedral reconstruction. So when you don't, it's a new virus, you don't know how does it look like, but you have a basic of literature that it belongs to icosahedral family, right? So you give the software what do you say, a comparative model, like put a icosahedral kind of a map on this, what we have got. So it arranges things according to the icosahedral reconstruction. Since we knew that FCV falls into icosahedral thing. But this point, if we give it a model to put it as a mask on the shape, so this will, not take care of any minute changes that has happened. It will just average out everything. So this is what we got here. We were not able to see any difference here. So these are the VP1s. These are the P domains that you can see. We were not able to see any distinctions because we have employed this icosahedral symmetry. Although we got a resolution of around 2.7 angstrom, but still we wanted to see, because we were very sure there's something, because we had seen it in the negative stain. Here, since we gave it a average map. So it averaged out if there was any small uh, alteration has happened. So we went ahead with asymmetric reconstruction. We have not told him anything like it looks like that or this. So we asked him to give us a model without putting any kind of averaging so that we could know if there's any, thing alteration has happened. So if you'll see here, all this is intact, but there's a particular side where we see there's a loss of components of this VP1s. So this was very definite, like if you see here, there are VP1s arranged very nicely all throughout the capsid, but this particular localized center has the VP1s missing. So this is what we were looking for, and we are working on it now. So this, we have a resolution about 3.3, and now we are taking it further, adding more particles to it, collecting more data so that we could, get to a level where we can actually tell you at which amino acids and everything this breakage of VP1 is happening. So this was the one part, but as you can see, if you carefully see this micrograph, you can see there has been some very uniform components that are, out there, these triangular things. So we wanted to know what are they. So we collected these and we did the classifications and everything. And to our amaze, I mean, this was just a side study that we were doing as we just noticed them to be present in a very uniform manner. And to our amaze, these were a part of the VP1s, that is the P domains, just not the shell domain. I told you that it, initial slide, it composed of two parts. So this is the P domain that has come out. So now we are doing our studies to find out why particular that part, that side of the virus, is it the two-fold, five-fold, threefold? And why only the P domains are coming out? And where is the point of, break in? So this is under study right now. And then a very interesting fact. I mean, it's kind of you sometimes what you think in mind you are seeing, you don't get to see this, but it gives you unexpected things. We had the heat treatment, but we really wanted to give it an endosomal pH so that we could know what is actually happening inside the endosome. How is it reacting? So in addition to the heat, we treated it with the pH. So we were expecting the later stages of disassembly, like while it's exiting the endosomal and going towards the nucleus. So at this point, we were not able to, notice it when we were collecting the data. And we could see there are some particles which are very empty. Can you see that? The interior, there's nothing inside. So this denotes that something from inside has been lost and it's out. From the next micrograph, I'll show you. See. So this is a particle and there is an opening and this very uniform spherical thing is coming out, right? You see here also, it's opening at a particular site and it's coming out. The whole particle is not disintegrated. It's an empty particle, you see here. So this, after a lot of careful observation and discussions and everything, we saw that this is the genome, which is has, which is coming out, and that is why we're able to capture it at different stages of, exiting out the disassembly. So these small particles are the genome that have come out. These are the empty ones. These are the ones at the phase of exiting out. So now, since we have got a lot of different varied types of particles now, so we are on a task of collecting individually these and moving ahead. We did try with the 2D classes of the genome. We collected it, and we were not able to reach to a good resolution because it's very few particles. That's only 7,000. We are adding more. But what we got was this interconnected density. Everything is interconnected here. So this can be the phosphodiester bond that goes around in the nucleic acid. But we need to put in more number of particles to get a quite good estimate of what's going on. Yeah, so this video just summarize all about cryo-electron microscopy. This is the grid, putting a sample. This is the blot. They're all in different orientations. All are present in this leads to the formation of different duty classes. Thousands of them. From the globology thing, you can actually go and see the amino acids that have been, altered. Yeah. So this is it from my side. And I was lucky enough to have that IIT has the cryo-electron microscope with it. And we are able to process and see our studies, do our studies at comparatively easy level. So I'm working in the lab of Professor Manideepa Banerjee, which is at School of Biological Sciences.
Okay, so we had a wonderful journey regarding the structural elucidation of non-enveloped viruses. So on the behalf of organizing committee, I really extend my thanks to our speaker, Dr. Pankhuri Narula, ma'am. So now the house is open for discussion. If somebody is having any questions, please come up. You may drop your questions in the chat box as well. Uh, Let me quickly check the chat box. Right now, I don't see any questions coming. If anyone is having any questions, you may drop in the chat box. I can read for you, or you can just raise your hand. We can unmute you, or you can unmute yourselves. So please feel free to ask questions. I don't see any question. Then maybe one quick question from me, ma'am. It was wonderful talk, but I mean, I'm not a virologist, but I was just having some, yeah, wide anticipation, so to say. Like when this uncoating or this disassembly things are happening inside a virus. So, I mean, all the approaches, I don't know whether the question is very feasible or not, but mostly these events are analyzed on an ensemble-based method. I mean, like, can we check this event on a single molecule, like single DNA, single RNA level resolution in real time? Is it possible? I mean, then maybe we can find some more molecular events actually taking place in the cell. Yeah, I mean, I
Actually,
just
the
want your comment.
thing with us is this process, this assembly is very dynamic, is very transient. So
Mhm.
at the first place, catching a virus specifically at this point is a task.
Mhm.
We were fortunate enough. I mean, we never anticipated like we'll get to know if you'll see the micrographs, so different stages of disassembly. Like, so few are ones at the exiting and few are still opening up, and the few are just the empty ones. So we were also very, into the thing like, what if we just collect just a data set which all the viruses are at a single point of time, right? It will be very easy for it. It will be more homogenized study and a sample also. We tried, but we just could not catch them at a very definite step. We just, that is like playing with their nature itself. So we are not able to. So what we have done now is we have collected enormous data, and out of that, we are segregating these stages so that we can know, we have ample number of particles at that particular step, and we know what is happening at that point. But collecting them at a definite one step, it's not possible.
Yeah, fine. So I think Dr. Anjali Priya is having a question. Ma'am, you can unmute yourself. I have made you co-host as well.
Hi, Pankoti.
I
So it was a
how
very interesting talk.
Thank you.
And So I already know what you're working there in Manideepa ma'am's lab, and I was just curious to know that ये जो cryo electron microscopy का work है, it has been done there in only in Kusuma or from outside?
Yeah, we have a Sathi facility which is funded by the DST. So we have a cryo-electron microscope here in IIT.
Okay, okay. So
So
recently it has
every,
been installed.
yeah, it is, I mean, it was there from last 3 years now. So we already had a TEM in our department, you know. So all the
हाँ,
negative
temp तो
stain
I know. हाँ.
studies, yeah, and all the negative stain studies was done there, and the rest, the cryo, it's all from base scratch to this model refinement. It's all done in Kusuma.
That's great. That's great. तो ये अभी CRF में है, like we can access it, like
This
if we
is, yeah,
want
yeah,
some
this
sample.
is under the Sathi facility.
Okay, साथी facility.
Sathi
So
facility. So,
by paying some charge, we can get
exactly.
access of the facility,
Yeah.
right?
So you'll get a slot, you'll get the grids and everything.
Okay.
And if I mean, if you have a collaboration with Professor Manideepa, we can do the processing and everything is set up from the computing pipeline to the screening thing. So all
Okay.
every pipeline is settled now here.
That is wonderful. Wonderful.
Yeah. Yeah.
Thank you, Pankaj. It was a very nice talk. Thanks a lot.
You.
Sir, you can conclude now.
Yeah, so I mean, I can see lots of appreciation messages for Dr. Pankuri Narula. So, okay, so on behalf of organizing committee, please join me virtually to transfer the memento for Pankuri ma'am. Just a second, I will share my screen. Yeah.
Thank you so
So
much.
thank you, ma'am, for accepting our invitation, and it was really a wonderful talk, so to
It
say.
was a pleasure. Thank you.
Thank you.
Thank you, Pankaj.
Thank you. Bye.
Okay, bye-bye.
Okay, so with a wonderful start of the second half with a journey regarding this non-enveloped viruses, we move forward with our next speaker, Dr. Dhananjay Singh. Sir, are you on board? Pankuri ma'am, you can stop sharing your screen. Thank you. Yeah. Uh, uh, Sir, Dr. Dhananjay, sir. Um,
Yeah, now it is done. Yeah,
Hello.
Somnaji, it is done.
Yeah, yeah. Now
Yeah,
it's working.
now I'm
Working. Yeah, yeah.
okay.
Yes, sir. So, like, can you switch on your video, sir? Think.
Yes.
Okay. Yeah. Okay. So, with the next session, the next talk for our 5-day FDP faculty development program. Let me welcome Dr. Dhananjay Kumar sir. Welcome, sir, on board. So, before I hand over the stage to you, let me have a quick introduction. So, Dr. Dhananjay Kumar sir, he is working as an associate professor in the Department of Zoology at the Central University of Jammu. He earned his undergraduate and postgraduate degrees in biosciences from Jamia Millia Islamia, New Delhi, followed by a PhD in zoology from Banaras Hindu University, Varanasi. Dr. Kumar has an outstanding research career spanning India and abroad. He completed postdoctoral research at the Narayana Netralaya Foundation, Bangalore, worked as a Serb Young Scientist Fellow and DST Cognitive Science Research Initiative postdoctoral fellow at IIT BHU Varanasi. Later, he joined the Miguel Galili Research Institute, Israel, where he investigated diet-induced circadian disruption in mammals. His research focuses on circadian biology, chronobiology, neurobiology, cognitive science, inflammation, fibrosis, and natural product-based therapeutics. Dr. Kumar has successfully completed SERB and DST-funded projects and currently leads an ICMR-funded research project worth rupees 75 lakhs. He has published 20 research papers, 2 book chapters, and holds a national patent. An invited speaker at numerous national and international conferences, Dr. Kumar also serves as a reviewer for leading scientific journals and reviewer for DBT, Government of India research grants. So, welcome, sir. Welcome on board for the faculty development program. So, the stage is yours.
Thank you, Somnaji. So, so since the topic of that FDP is on frontiers in bioinnovation, innovation in bioengineering, biopharmaceuticals for healthcare industry and sustainability. So I've chosen the topic related to this. Actually, there are a lot of uh, things going on in today's modern society. We are disrupting means our day-to-day activities or lifestyle has resulted into a lot of chaos and is responsible for many disorders, metabolic, physiological, as well as neurological disorders. So there is an urgent need for some drug, and that too some n- natural drugs which has least side effects and can help in re-synchronizing our body clock to the normal life, to the normal environmental world. So, hence, the topic of my presentation today is exploring the therapeutic potential of nutraceuticals in resetting the dysregulated or disturbed biological clock. So, I'll just give some introduction. So, recently in 2025, uh, a field in biological science received Nobel Prize for physiology, and that branch of biology is known as the circadian biology. So the scientists explored the underlying mechanism how the plants and animal adapt the circadian clock. So nearly three scientists were awarded the Nobel Prize for physiology in circadian biology. Circadian biology is not a new concept. It is it is age old concept. It's an ancient concept which our ancestors have used. So, nearly after 200 years of exploration by the scientists, the impact of circadian rhythm create, created by the Earth's 24-hour light-dark cycle, because the Earth rotates, hence the light and dark is observed, were recognized by the world top-notch scientists. However, with the discovery of the circadian clock, the modern medical recommendation to how to live in a balance with the circadian cycle of light dark cycle and seasonal changes are still a topic of debate today, and people doubt this. So, how Ayurveda and circadian medicine existed long back. As I told, it's an ancient science. So, since Ayurveda is an ancient science for healing our mind and body, and it has integrated circadian medicine into protocols and the treatment plans. You cannot take any medicine at any time as prescribed by our uh, doctors. Therefore, the foundational strategies in Ayurveda that related to the circadian medicine has been known as rasayanas. So, what are rasayanas? Rasayanas are basically the lifestyle protocol that promise rejuvenation, longevity, and higher states of consciousness. In our Ayurvedic textbooks, these rasayanas have been characterized into four major categories. The first is Vihara Rasayana. That means it deals with the lifestyle or aligning our biological clock with the natural world, like 24-hour light dark cycle to balance between the daily and the seasonal routines. Then second is the Ahar Rasayana. The Ahar means food. So it has to do with the food. Secondly, the Acharya Rasayana having to do with your behavior. And last is the Anusandhana Rasayana having to do with herbs. Anusandhan means research, and the research using the herbs. So Ayurveda makes the case that Rasayana supports health, longevity, and spirituality by maintaining a connection to nature and circadian cycle. So these four rasayana could live under a large umbrella. It is known as circadian rasayana or circadian medicine. These ancient practices suggest that living seasonally offer an opportunity to align ourselves with nature. For example, in Ayurveda, winter or water season is there, where it is cool and dry, and naturally balanced by the heavier and fattier food. That's why you have observed that during the winter we used to crave for fatty food like the parathas, samosas, and other stuffs. So during this spring, or which is known as the kapha season, is heavy and is damp and naturally balanced by the harvest of bitter foods. During the winter, when which is the vata season, which is cold and dry, and naturally balanced by the heavy and fattier food, as I described. During this summer, pitta season is there, and this is naturally balanced by harvest of fruits. Pitta means acidity, so it can be cooled by fruits and using vegetables. So I will just introduce you all with some basics of circadian biology, and then we'll go into detail how the one of the nutraceutical like uh, Brahmi, how I have used for my research and how it has given some result. So as we all know that we are exposed to the light, and light consists of the electromagnetic spectrum. So the electromagnetic spectrum of light starts from the X-ray, gamma rays, X-rays, ultraviolet radiation, visible radiation, then infrared, so on and so forth. However, for human, we are basically focusing on the visible radiation, which ranges between the 400 to 700 nanometer. Vibgyor, as we say, that is the violet, indigo, blue, orange, red. So these all colors of light plays vital role in resetting our circadian clock. And as we all know that light has both, it has dual nature. That is the particle as well as the wave nature. So we describe light in terms of photon. that is the energy of light in terms of photon. That means we have studied from our 7th or 8th class that E is equal to h nu, nu is equal to c by lambda. And we clearly see that the energy is inversely proportional to the wavelength of light. Our eyes have lot of photoreceptors which senses lights of various colors. Apart from the color photoreceptors, our eyes also has non-visible photoreceptors, which are known as intrinsically retinal photoganglionic cell (IPRGCs). So when the light falls on the retina, as you see, a lot of photoreceptors are there. You can see the rods, which is gray in colors, then the cones, which are red and blue colors, and you can clearly see the IPRGC, intrinsically photosensitive retinal ganglionic cells. These IPRGCs are known as non-visual photoreceptors. These IPRGCs are primarily responsible for resetting our biological clock, which is located in our brain. So you can clearly see that the different cones, S cones, melanopsins, rods, all these cones senses different wavelength of light in this diagram. So keeping in mind these basic terminology will further goes through. There is one instrument for heart we use electrocardiogram. Similarly, for our eyes to measure the activity of retina, we use another instrument known as electroretinogram. This records the retinal event, and you can clearly see when you give a light, you get peaks like A wave, then B wave, then oscillatory potentials. So these kind of waves you get, and these waves tells primarily about the various type of photoreceptor which are being elicited by various wavelength of light. So this is the diagrammatic representation of our retinal cells. You can clearly see the rods, the cones, then the retinal ganglionic cells, and all these rod cones and RGCs are primarily responsible for transmitting the light signal to our brain through a connection known as retinal hypothalamic tract. So, as we all know, that nearly all the organisms on the earth exhibit near 24-hour rhythmicity, not only in physiology, behavior, but in biochemistry, the molecular aspect, the metabolism. So many of these daily rhythm has the periodicity close to 24 hours. That is close to light dark cycle. When how we have discovered this? When we keep the organism under constant condition without changing the light dark cycle, we still see the presence of periodicity or the 24-hour rhythmicity in behavior also, physiology also, and the biochemical parameter changes in a periodic fashion. That clearly shows that all these parameters are regulated by a clock which is present somewhere. And that clock, as I have already told, is located in the brain. And these clocks are primarily regulated by the light. There are other factors we will discuss further, which regulates or resets the circadian clock. So this 24-hour rhythmicity is maintained by a circadian clock, which is also known as the master clock. And these clocks are, as I told, is primarily reset by the light, the drug, the food, temperature, and various other factors or cues in order to entrain or synchronize with the environmental cycle or rhythmic cycle. So, what is circadian? So, circadian rhythm is very important to maintain the synchrony between the environment and behavior, physiology, and metabolism of an organism. So, this is the diagrammatic representation from one of the research paper I have taken the figure. So, master clock, this is the SCN where it is located. It is also known as the endogenous clock or suprachiasmatic nuclei, SCN. and these SCN regulates or controls various peripheral organs or peripheral organs like the heart, kidney, lungs, and other part of the brain. And these peripheral clocks are regulated by photic and non-photic cue or factors, as I told previously. The non-photic cue like sound, food, drug, temperature, and primarily light. So light through the, as I told, goes through the retinal hypothalamic tract to the SCN, send the information of light to the SCN due to presence of certain molecular component, which I'll be discussing later. These SCN regulates, due to change in the molecular aspect, regulates various peripheral centers or peripheral clocks present within the brain as well as outside the brain, such as like our mood is regulated by some centers present over here. The sleep is regulated by center present in the brain. Then the the brain homeostasis is present in cerebellum region. Then our hormone secretion of hormones are regulated by some endocrine factors, which are released from the peripheral clock present in the endocrine glands. Then the temperature also regulates our liver, that controls our blood and blood glucose and triglycerides, as well as the kidney, which helps in clearing the toxic products, and the heart, which is responsible for supplying the blood or maintaining the blood pressure. So all these uh, clocks or the peripheral clocks or secondary clocks are regulated by the primary clocks present in our brain, which is known as the suprachiasmatic nuclei. And these peripheral clocks and behavioral clock has, or in these clocks, various transcriptional and translational feedback loops operates, which controls the molecular mechanism, and these molecular mechanism regulates physiology, behavior, metabolism, and biochemical aspects in our body. So I will briefly describe, like, inside the nucleus there are two important proteins known as the clock and BMAL. These clock and BMAL protein dimerizes with the enhancer element or the promoter region of various genes like the period genes. There are period 1, period 2, period 3, and then the cryptochrome genes like cry genes. There are cryptochrome 1, cryptochrome 2, and other genes like RevERB and ROR. So when clock and BMAL heterodimerize, it regulates or it controls the expression of period genes, and these period genes, they gradually builds up in the evening and reaches peak in the night. They get converted or translated into protein in the cytoplasm, where the period and the cry protein are phosphorylated by several factors. These phosphorylated period and cry protein, they dimerizes and they gets translocated in the nucleus, where they inhibit their expression, or mean where they inhibit the clock and BMAL, thereby regulating the expression of their own genes like PER and CRY, as well as the REV and ERB genes. So we can clearly see the two type of loops. The positive loop, that is the clock and BMAL, accelerates the production of PER and CRY, whereas the PER and CRY, when they dimerize, they inhibit its own secretion and RevERB secretion. The another protein, the Rev and ROR protein, the Rev protein negatively inhibit the expression of BMAL, and ROR, it positively expresses the it regulates the expression of BMAL and clock. So the clock protein and BMAL, there is a cyclicity. So because of these events, there is a cyclic events of rise in the PER and CRY protein. These PER and CRY proteins are essential components of our biological clock, which regulates various physiological, behavioral, and metabolic events in our body. and in our body. So any disruption to this molecular clock leads to various physiological, metabolic, and neurological disorders like sleep disorder, hypertension, diabetes, cancer, as well as the cognitive deficit. So, as we have seen, disturbing of these clocks in the present society, we can see we are disturbing ourselves, we are exposing ourselves to blue light, as I previously described that E is equal to h nu, nu is equal to c by lambda. That means energy is inversely proportional to the wavelength. So shorter the wavelength, higher is the energy. So in we are exposing ourselves in the night to a lot of mobile, computer screens, televisions, and some fancy lights in our surrounding environments. So mostly the blue light, which is having the shorter wavelength, is most powerful in disturbing the biological clock. We all know that during the night, a hormone known as the melatonin, and we have studied that melatonin is a night hormone. So when we are exposing ourselves to the blue light, the level of melatonin, which should be at the peak in the late night, it suddenly declines, and melatonin is having pleiotropic role. Melatonin is responsible for many, means it has many roles. It is acting as an antioxidant. It regulates your reproduction. It regulates your biological clock. So, it so any disturbances to this hormone may disturb the physiology of your body or biochemistry of your body. So this has led to means various cancer in the people who are exposing themselves to untimed light in their surroundings. So primarily the night shift workers who are mostly working in the call centers, hospitals, the flight attendants. So they are constantly exposing themselves to the light during untimed light exposure. So in 2007, it has International Agency for Research on Cancer classified shift work and jet lag as one of the factors which is responsible for causing cancer. They have grouped this shift work as a circadian disruptor and has grouped into a 2A, a probable carcinogenic agent to humans. So this is the some of the diagrammatic representation how our master clock is affecting various biological clock and secretion of various neurotransmitters, how it is impacting and then leading to disruptions of various tissue cells in our body. You can clearly see that the light from the eye impacts your hormone secretion, your body temperature, your lymph node, that is the lung, your thermogenesis, that is brown fat. Now people are getting obese because of untimed exposure to light, eating during the night time. Because of this, the thermogenesis occurs and the accumulation of bad fat, that is the white adipose tissue instead of the brown adipose tissue. The heart rate is dysregulated. Recently, we had a paper in 2026 that how circadian disruption as a result of increased salt and sugar intake leads to hypertension in rats. Then the liver clock is impacted, your metabolism will be. So there are numerous factors which are being impacted just because of untimed exposure to the light. So the circadian desynchrony or disruption as a result of untimed exposure to light, you can see the left and the right hand side, the day shift worker. For humans, if we see, mostly the humans are active during the yellow phase, that is the light phase, the activity is there, and they go to sleep somewhere in the evening, still some activity is there. However, in the night shift worker, the activity pattern has completely shifted towards the darker phase, that is the grayish phase, which is the light dark phase. and you can see the level of various hormones like melatonin. In the day shift worker, it peaks around late night. However, in the day shift worker, the level has been blunted. It has lowered down. The cortisol, which for human it should peak in the early morning with the onset of light, that is when you awake, because cortisol is responsible for various breakdown. You need energy, so cortisol is one of the factors. So in day shift worker, there is a very good peak. You can clearly see the rise in the cortisol with the onset of light, and there is the lowering of cortisol in the night. However, in the night shift worker, you can clearly see that the cortisol level is also dampened. It is not rising. It is dampened. The core body temperature is also affected. Your oral mucosa, that is the mouth, the expression of period 3 gene has been blunted in night shift worker. Per3 gene is one of the marker for circadian marker for disrupted circadian clock. Then in PBMC, you can also PBMC. Uh, in blood, you will find that the per3 has been blunted. In your hair follicles, you see nowadays people are getting bald because you disrupted your circadian cycle. Hence, your hair follicles, there is the rhythmicity of per3 gene in your hair follicles. It has also been blunted. So the causes of circadian disruption has lead to various disorders like sleep disturbances, cognitive impairment. A lot of accidents you can see early in the morning when people are driving in the night. There is cognitive decline and other mental disorders like sleep apnea, the cancer risk, gynecological problem like PCOD and PCOS, digestive issue, and the endocrinological disturbances has been observed. So what we have done, we have used one of the natural products from the Bacopa moneri, that is Brahmi. So this Bacopa moneri is, it is isolated from Brahmi, and it is an Ayurvedic drug. Like this has been used as a brain tonic for improving the intellect and memory for several centuries in our society. However, uh, the Bacopa moneri has several extracts, and the presence of these, nerve boosting tonic or memory is because of the presence of a specialized component known as bacoside, and these bacosides are basically saponins. So its neuropharmacological roles in various disorders like insomnia, depression, psychosis, epilepsy, and stress has been extensively studied. However, its role on biological clock is still lacking. Hence, we took Bacopa moneri and we try to establish as a chronobiotic molecule which will help in resetting the biological clock. So, what is chronobiotic? Chrono means related to time, and biotic means natural product. So, we are using a molecule which can reset our biological clock when given at a right time point. So, for this, we use some of the recording system for our mice. So mice were placed in this kind of wheel which has various transmitters which transmit the signal from the wheels to the computer. The computer generates the locomotor activity pattern. These locomotor activity pattern can be used as non-invasive biomarkers of circadian clock. We can see whether the animal is having the clock intact or whether it is dysregulated. So we also simulated our mice in these instrument jet lag kind of situation in the laboratory. So if you see here white and the dark bar, it clearly white bar means the light period. The light is on 6 in the morning and off around 18, that is 6 in the evening. And then again next day 6 in the morning and light off 6 in the evening. So dark means complete darkness, light means. So since we have used mice is a nocturnal animal. So what it mice basically are active during the night time. So this is the diagrammatic representation of a protocol which we have induced in our mice in our lab setting. So basically, the mice should be active during the dark period, and it and they will be under rest. You cannot, I mean, you see the thin lines. That means they are not doing any activity. And then what we do after when the animals are synchronized to the light dark cycle, we used to advance the lighting schedule by 8 hours for several weeks. So when we advance our lighting schedules, the mice faces problem in resetting the circadian clock to the new lighting schedule. Hence, uh, the mice are under stress, and which is represented by the red color. And this red color, you won't see the clear activity from. I mean, in the new LD cycle, there is the activity is gradually increasing to the new LD cycles. So this cycle is known as the transient cycle, where our body physiology, metabolism, um, biochemical, endocrine parameters all are disrupted during this transient cycle. And it takes several days, nearly 10 to 12 days in some of the animals to resynchronize or re-entrain to the new LD cycle. This re-entrainment or locking to the new LD cycle is known as re-entrainment. Similar, we have condition we have simulated in our mice. So we have used AKR strain and kept in 25 degrees centigrade plus minus 2 degrees centigrade in 12-hour light and 12-hour dark cycle. This was maintained with the help of a electronic timer, and mice were fed ad libitum. Then the mice were randomly divided into 5 groups, and each group consists of 5 animals. First group is known as non-treated control. Second is vehicle-treated control. We have used gum acacia in twin 20 plus what do you call and then we have used bacoside, in which we have used 40 milligram per kg body weight, and then 80 milligram per kg body weight. And in the last 5th group, this third and fourth group, what we have done, we have stopped the bacoside treatment after, I mean, the jet lag is over. But what we have done, we have continued the bacoside treatment in the mice till the end of the experiment when we sacrifice our mice. So after simulation of the jet lag condition, after so initially for mm, 10 days, 10 to 12 days, the animals are aroused to free run into 12 to 12-hour LD cycle, and then after a stable entrainment, we have advanced the LD schedule, which is known as the jet lag protocol, for 8 hours. And similar advancement has been done, means 3 times. So this is the kind of situation which we observe in our daily life. We have seen some of our relatives are working like at one time they will be working from 6 in the morning to 6 in the evening, or from 9 in the morning to 9 in the evening. And then after 1 or 2 weeks, their schedule has been changed from 3 in the morning to late in the night, around 3 to 4. And then again, if we advance, then it get back to the original 6 to 6 LD cycle. So this is basically a chronic jet lag kind of situation or shift work like situation. The animal, as I showed you, that the animals take some time to reset their biological clock to the new LD cycle. That point is named, or the time point is, or time period is known as the transient time period. And we have used software to monitor these kind of activity, which is known as the clock lab software. So during these transient period, we have subjected our mice to various neurological tests, like to see whether the animals are, I mean, their cognitive ability are intact or not, and to see whether, I mean, they have learned or not, whether is there any impact of the jet lag or chronic shift work on their learning and memory. For this, what we have done, we have subjected our mice to spatial acquisition. We have used Barnes maze to to find out the cognitive decline in learning and memory. So what Mars maze is basically a round table with 20 holes at equidistance. The hole is around 5 centimeter, and we put the mice in the center, and mice used to search. Mice is having the ability to find out new things. So it will be searching things. So first we train the mice for for 3 minutes for 4 trials every day, and once they are trained, then what we used to do, we used to rotate the table, and we used to place what you call uh, some food which the mice tries to explore. So we wanted to see whether the mice takes less time because they have already trained it for uh, for 4 trials. So we wanted to search for the short term and the long term memory or retention. So for that also we for short term memory, after 1 day we used to leave the animal in the center of the table for 90 seconds, and then the mice used to search for the target holes. If the mice remember the target hole, it will reach the hole very fast. It will take few seconds. Otherwise, if there is cognitive decline, if their memory is impaired, it will take a lot of time to search the holes. After this, we we do not treat the animals except the fifth group, which were given continuous treatment. We used to test the same thing for the long-term memory, whether they are recalling, whether whether their memory is intact or not. So after 5 days of the previous test, then again we are looking for the long-term memory, and we have used three strategies for this Mars maze. First is the direct, that is, the mice will move directly to the target hole or nearby holes to look for their food. Secondly, the mixed strategy where the mice will search the holes by crossing through the center of the table. And third is the serial hole. It will first visit to the target hole, then at the back, and the previous hole, either in the clockwise manner or in the anti-clockwise manner. So, and the second test we use is the novel object recognition test. The novel object recognition test is known as the NOR. NOR also checks for the impairment of hippocampal mediated task. Hippocampus is present in our brain, which is responsible for episodic memory. So rodents, basically they are having the name of exploring the new things. So what we do, we first take a square box. In that square box of specific dimension, we put the mice for some times without having anything. So we are basically habituating the animals to freely explore that box, and then we train the mice in the box and allowed to explore that mice for 5 minutes and then return to their home cage. When the mice are familiarized, after 24 hours, we will place one familiar object from the training period. And then we will see whether the mice is exploring or not. And then we will remove that familiar object and place a new object close to that familiar, one object. The mice, and then we want to see whether the mice is exploring the new object, giving more time to the new object, or it is going confused and it is exploring the familiar. So when the mice explore the new object, that means its memory, episodic memory or hippocampal memory is performing well. And if it spends more time, or if it is not exploring, uh, if it explores more time on the familiar object and not exploring the novel object, then we see we come to the conclusion that there is cognitive decline in the mice as a result of circadian disruption during chronic jet lag or shift work. So then we calculate the discrimination index, means whether the mice can clearly discriminate between the familiar and the novel object or not. And the formula is the time to explore the novel object minus time taken to explore the familiar objects into 100 divided by total exploration time of both the objects. So if the DI comes positive, that means it has preference for novel object. That means the animal cognitive ability is perfect. When the DI value is zero, it is confused, and that means it do not show any preference, and there is cognitive decline in both the DI value zero and DI value negative. So another test we perform is the we have treated the five mice at different time points, 3 hours apart, and we have seen how the circadian clock resets the locomotor activity rhythm, and we find that when we give the bacoside at various time points, there is specific response, that is shift in the activity pattern from the normal to either it advances or delay. So we have plotted that shift, which is known as the phase shift in the locomotor activity pattern, and we have plotted in the Excel, and we see a clear-cut pattern in response to the bacoside. That means bacoside is clearly showing the chronobiotic effect. If we give bacoside at ZT3, it shows maximum phase resetting, and when we give bacoside me in the early night, there is the negative phase resetting, and in the late night or early morning, there is a positive resetting. So keeping in mind this, we have constructed a graph or a wave which is known as the phase response curve for the bacoside, and CT is the circadian time. So this is the actual data of our mice. We can clearly see that initially you see the light is on at 6 and off at 18 hours. This is 12:12 hour light dark cycle. This first phase, that is LD 12:12, clearly you see that animals are active during the night time. And when we advance the lighting schedule by 8 hours, when that is when light is on at 22 in the night and off in 10 in the morning, you clearly see that the animal is advancing their lighting, activity schedule. However, the animals are confused. We have advanced the lighting schedule 3 times so that it acts as a chronic shift. And you clearly see, like for every individual who is normal, their biological clock clearly follows a 24-hour pattern. So in the initial stage, when the animal is following the environment, external environment 6:6, the LD schedule is 24 hours. You can clearly see the time endogenous periodicity here, clear 24-hour peak. However, during the jet lag condition, when you advance, you see the periodicity or the period has declined to 21.8. And when you leave the organism after the last advance, the animals take several hours. You can clearly see the activity in the white, during the light period also. But the sum of the activity is starting to settle. And I have used the last 7 days to see the periodicity, where the post jet lag periodicity is around 24 hours. That means light, changing the light schedule of the animal is disturbing the biological clock of the animal, clearly observed by the change in the periodicity of the animal during the pre-jet lag, or shift work condition, or post-jet lag, or post-shift work condition from this graph. These are the same graph of different animals after advancing their clock by 8 hours. So you clearly see the animal in the control group, their during the jet lag, their activity pattern is highly disturbed. In the vehicle, still disturbed, but in the bacoside treatment, you clearly see the disturbances in the LD schedule is minimal. So our data clearly shows that bacoside is having the phase resetting property. So as I told you that the endogenous periodicity of the clock has been disturbed due to the light schedule. You see we have uh, shown here the periodicity of the various animals during the pre-jet lag condition and during the jet lag condition. The pre-jet lag, which is 12 to 12 hour fixed lighting condition, 6 light on, 6 in the morning, off, 6 in the evening. The periodicity is 24 hours. But when we, during the jet lag or shift work condition, the periodicity has declined, and you can see there is no clear-cut peaks for the periodicity. That means the animals are highly disturbed. So this is the activity profile of the animals. During the jet lag condition, you clearly see the animal is active throughout the day and night. However, during the pre-jet lag condition, the animal is only active during the dark condition and rest during the light condition. So what we have done, we have used some of the markers or non-invasive markers of the biological clock, which is very evident nowadays. People are looking for biomarkers. So we can clearly see that the number of transient means the disturbances or time taken by the animal to re-synchronize or re-entrain to the new LD cycle. The animal who are meaning control condition takes nearly more than 16 to 17 days to resynchronize their activity to the new LD cycle. Vehicle also takes larger time. However, the bacoside treated animals take significantly lesser times compared to that of control and the vehicle. So from the previous diagram, we clearly see here that the onset of activity and the offset of activity. Here you clearly see that the onset of activity resynchronizes or re-entrain faster than the offset of activity takes more time. So in this figure, the control animal, the offset of activity in both control and even the jet lag relatively takes more time, but compared to the control and vehicle, the bacoside treated animal takes relatively or significantly lesser time compared to the onset and offset of activity in both control and vehicle animals. So for the cognitive test, as we performed that the noble object and Barnes maze, you clearly see that the time spent in probing me in exploring the novel object in both the diet treated 40 milligram, 80 milligram, and 80 milligram continuous treatment, the animal explore more time to the novel object compared to that of the familiar object. That means there, I mean, cognitive, there is no cognitive decline during the pre-jet lag condition. So during the jet lag condition, you see the exploration time by the animal in control and probe. You see there is lesser time used by the control animal to explore the noble object compared to the familiar object. However, you see here the 40, 80 and 80 continuous milligram per kg body weight of bacoside. During the jet lag condition, the animal explored more time to the novel object. That means the bacoside is helping to improve their episodic memory, and that means it plays an important role in maintaining the clock inside the hippocampus, thereby impacting the learning and memory in the mice. Similarly, the Barnes maze, you clearly see that the animal treated by 40, 80 milligram relatively takes less time during the jet lag condition compared to the control and vehicle. That means the bacoside clearly, the treatment with the bacoside clearly improves the cognitive decline in cognitive deficit mice, or that boosts the cognition. Similarly, we monitored for the endogenous periodicity as I showed, and during the jet lag condition compared to the pre-jet lag, the endogenous periodicity of the animal significantly declines compared to pre-jet lag and post-jet lag, which is 24 hour. However, during the jet lag condition, it is around 21 and 18 to 19. The activity time also declined during the jet lag condition. That means animals are confused, mostly sleeping during the night time or during the active period. So the alpha means the activity. So alpha also declines during the jet lag condition. However, treatment with bacoside has improved alpha. So the fear conditioning we also perform fear conditioning, and we can clearly see that the after pre-jet lag and the post-jet lag, there is no clear-cut difference. However, during the jet lag, when bacoside treatment, we clearly see that the bacoside improves the animals are able to recognize for the we expose the animal to shock, so the animals brain is functioning properly and are properly responding to the to the food shock or the condition which we are giving, that clearly shows that bacoside is improving their cognition or cognitive ability in mice. So, as we all know that acetylcholine is one of the neurotransmitter which plays important role in transmitting the nerve signals. So we measure the acetylcholine. Sometimes the acetylcholine, the level of acetylcholine in the jet lag condition is altered. However, in different region of the brain, PFC, hippocampus, and SCN, and we clearly see that the bacoside-treated animal during the jet lag condition improves the acetylcholine, which is a neurotransmitter, and also improves the acetylcholinesterase, which degrades the acetylcholine. Hence, uh, we can clearly see show that or say that the bacoside is improving the neurotransmitter level as well, which is responsible for, sending the signals to the brain and different parts of the body. So we also monitored the flow of blood in the animals, and we saw that the bacoside improves the blood flow in the mouse brain. We measured mitochondrial bioenergetics. We perform mitochondrial bioenergetics, and we have seen one of our papers have shown that the energy level also fluctuates in the our biological clock. That means there is a rhythmic requirement of energy level in the brain over a 24-hour cycle. And if we disturb the master clock, the cycle energy get altered, and we have shown that the bacoside improves the mitochondrial mitochondrial bioenergetics in both in the suprachiasmatic nucleus as well as the hippocampus. Then we use some of the other endocrine markers like the corticosterone and testosterone. And when you are under stress, the corticosterone is highly blunted or is highly elevated. So the corticosterone is, treatment with the corticosterone, bacoside has improved the corticosterone level compared to the jet lag and control animals. So next, the testosterone level was also highly elevated in the control animal, and it was very low in the jet lag. But the bacoside treatment has relatively improved the testosterone level compared to the jet lag condition. This clearly shows even the reproduction is also being impacted by jet lag or shift work condition. So bacoside is having potential to improve the clock or the peripheral clock in the reproductive tissue as well. So So recently we are under process, and I'm showing one of the drug which we are using from Withenia somnifera, and we are giving the Withenia somnifera at different time points, and we found that the time is having differential effects on the corticosterone level. So at ZT6 means around noon, and ZT18 around late, around 10 o'clock in the evening, we have measured the corticosterone level in the mice which are exposed to 16 hour of light and 8 hour of darkness. That means prolonged exposure to light condition, chronic prolonged exposure to light condition for 35 days. And we have found that the untreated animal, the corticosterone level at ZT6 was very high. Actually, corticosterone, as I already showed in initial slides during the introduction, that corticosterone is very essential for onset of activity, which is morning in the human and evening in the rat. You see here that the cort level is in untreated mice is highly elevated during the uh, morning time, which is the rest time for the animals. That means the corticosteroid level is blunted over here or is altered or disturbed. However, treatment with the Methania somnifera has decreased the corticosteroid level at ZT6. That is during ZT means right giver time. And in the night, you see the bacoside treatment has significantly improved the corticosteroid level compared to the untreated and vehicle treated mice. That clearly shows that nutraceuticals, if given at a right time point, means every nutraceuticals has uh, a, plays vital role if given at a specific time point of the day. That means it has a chronobiotic effect. So for bacoside, we clearly shows that our result clearly shows that bacoside has significantly reduced the number of transients by accelerating the rate of entrainment to the new LD cycle. It has decreased the active, uh, so it has improved the percentage of activity in the bacoside treated animal who were under the jet lag condition, and thereby improving the activity pattern of the animals. Secondly, in the jet lag condition, the activity was shrink during the chronic jet lag condition. However, the bacoside treatment animals, the activity was well dispersed during the active period of the animals. We also saw that the endogenous periodicity was impacted during the pre-jet lag and post-jet lag condition. The animals were 24, showed 24-hour periodicity, whereas during the jet lag condition, the periodicity was around 21, 19, 18, and that shows clearly disturbance from the 24-hour LD cycle. Our behavior test further substantiated that bacoside improved the cognition and learning tasks in animal. Then we performed immunohistochemistry and we have shown various markers, that is the clock and BMAL expression in different regions, the hippocampus region and the suprachiasmatic region and the prefrontal cortex of the brain at ZT19. ZT19 is the time at which when bacoside was given, it shows maximum effect. So you can clearly see the expression of these clock and BMAL, which dimerizes and influence their own expression as well as the expression of period and clock genes, which is responsible for maintaining the rhythmicity or cyclicity of the animal, for maintaining the physiology, behavior, metabolism, other stuff. So these are, period, different types of, period one and period two genes. Then cyclic GMP we have taken. Why cyclic GMP? Because cyclic GMP bacoside also is known to improve the blood flow. Blood flow means nitrogen, NO level. So NO level and cyclic GMP influences the cyclic AMP, which influences the nerve transmission. Hence, the cyclic GMP was also improved in the SCN level when treated at ZT19. So, the treatment with bacoside prevented the hydrolysis of cyclic GMP by phosphodiesterase, especially by phosphodiesterase 5, and help in improving the disrupted circadian clock. Then we look for the what you call neurogenetic markers, and that is BDNF, and we found that the expression of BDNF in the SCN was improved at ZT19 in the bacoside treatment compared to the untreated and vehicle treated animal. So then our question arises whether there is any chronopharmacokinetic effect of the drug. We wanted to prove. We have shown by our circadian markers, but we wanted to prove. Hence, we performed a pharmacokinetic study using the bacoside. So we have taken rats and then we placed those rats in 12 to 12 hour LD cycle, and then we have given rats bacoside through through two routes. One is intravenous and another is oral routes at two time points. That is ZT3 early in the morning after onset of after 3 hours of rest, and at ZT19 after late in the night when the animals are most active, at these 2 points, we performed chronopharmacokinetics of the bacoside, and we found that when at ZT3 and intravenous and the oral, you can clearly see that the intravenous, the chronopharmacokinetics when given in the blood, it when the pharmacokinetics of the drug is very fast and it starts diminishing after 24 hours. But when we gave the same drug through the oral means, it took a lot of time to show its maximum effect. Then at ZT19, you clearly see here the amount or the concentration of bacoside which was detected in the plasma is much significantly high when um, compared to that given both at ZT3 and ZT19. That clearly shows that the animal bacoside when given in the night shows most promising effect than, or it is more available in the blood compared to that when given in the morning. So time of dosing of drug is plays uh, vital role in impacting various factors in our in animal's body. So these are the various PK parameters when animals were given oral, intravenous as ZT3 time and ZT9. You clearly see the maximum concentration in nanogram per ml is nearly 3 to 4 times at ZT19 when we compare oral at ZT3 and ZT19, and the time taken by the drug to reach the maximum is much before me. Uh, it is much before here. You clearly see it is around 6 compared to that. When given at ZT3, it takes more time to show its maximum peak at ZT3. Then the area under curve, it takes it is around 2 times of the area under curve when the drug was given at ZT3. And the bioavailability, the drug available in the body of the animals were much higher, 2.3 times higher at ZT when given at ZT19 compared to ZT3. That is the inactive period of the animal is ZT3 and the active period of the animal at ZT19. So the relative oral bioavailability was 200 times more, nearly 200 times more in the rat given at ZT19 compared to that at ZT13. So overall, we can clearly show that circadian disruption due to change in the lytic schedule impacts or learning and memory and results into cognitive decline. However, treatment with bacoside, right time treatment with the bacoside can improve both short-term and long-term memory caused by desynchronized circadian clock during the jet lag condition and improves the endogenous periodicity close to 24 hours. This clearly shows that the bacoside is having the chronobiotic property similar to the drugs like the non-photic drugs like the melatonin, serotonin, and 5-hydroxytryptophan. Therefore, we can use first chronobiology as a non-invasive biomarkers to see like alteration in activity, onset time, and periodicity. Second, bacoside is having the therapeutic potential in resetting the altered circadian clock and enhances the re-entrainment to the new LD schedule. So we can use bacoside in managing sleep disorders by, and this will help in improving the industrial workforce and outsourcing personnel who are working in various industry, hospital, call centers, etc. This will lead to improved shift work and will reset the altered circadian clock. So this was my results. Hence, we can clearly see suggest that there is urgent need for various nutraceutical molecules in huge number of nutraceuticals molecules are there in our Ayurveda. We can choose and explore those nutraceuticals to target various kind of disease and disorders which are prevalent in today's modern society. So thank you very much. This is for today.
Okay, thank you, sir. Thank you for this wonderful presentation. So I now open the house for interaction. So participants, feel free to ask questions regarding the presentation. You can raise your hands or you can put your questions in the chat box as well. I see lots of appreciation messages. Okay, so if there are no questions, so thank you, sir. So I extend my heartfelt thanks for sharing your work. It was wonderful and it was very insightful, so to say, as it goes without saying. So please join me virtually to hand over the memento of appreciation to Professor Dhananjay Kumar. Let me share my screen quickly.
Thank you, Dr. Somnath, for giving me the opportunity to present something. I mean, my work over here, and I'm very happy.
It was our present, yeah, we are quite fortunate to have you here. So yeah, so thank you, sir, once again for your talk and in accepting our invitation on this faculty development program. Thank you once again. So I take a photo.
Thank you very much.
Just a second. Just I take a photo for the session. Yeah. Okay. So now we are done with two wonderful lectures, and now I move on with the third and last lecture of the penultimate day of this faculty development program. We already have Dr. Swantak on board. Welcome, sir.
Hello, Roy. Is it, am I
Yes,
audible?
yeah, you are audible. Sir, would you like to share your, I mean, can you switch on your camera? I will just take a moment to introduce you with our audience.
Is it visible?
Welcome, sir. Yeah, it's visible, perfectly visible. So, good evening, sir. So now I welcome Professor Swantak Kamsonlian on board. So he will be delivering the last talk of today's faculty development program, today's session. So before I welcome him on board, I mean to share his presentation, I just have a quick introduction. Let me introduce Professor Kamsonlian to our audience. So Dr. Suwanta Kamsonlian is currently working as an associate professor in the Department of Chemical Engineering at Motilal Nehru National Institute of Technology, Allahabad, Uttar Pradesh, since 2012. He earned his PhD in chemical engineering from Indian Institute of Technology, Roorkee, in 2007, and he had a BTech in chemical engineering from Kerala University in 2005. His areas of expertise and interest encompass environmental science and engineering, electrochemistry, biochemical engineering, and wastewater treatment. Dr. Swantak has made significant academic contributions, having published over 35 research articles in reputed journals and presented more than 30 papers at national and international conferences. In addition, he has authored 10 books and contributed 12 book chapters with leading national and international publishers. Prior to his academic career, he gained 2 years of professional experience as a safety auditor at Cholamandalam MS Risk Services Private Limited in Chennai. He is actively involved in research and consultancy projects funded by organizations such as SERB DST, NRF, GBT, TechWeep, CPCB, UPCST, and other agencies. His remarkable achievements include obtaining 16 national patents and 10 international patents in his respective fields of expertise. He holds memberships in professional organizations such as the Indian Institute of Chemical Engineers, the Indian Water Works Association, and the Asia Pacific Chemical, Biological, and Environmental Engineering Society. Moreover, he contributes to the academic community as a reviewer for international journals, keynote speakers, and resource person in various academic and professional events. So I welcome Professor Dr. Suantak Kamsondian on today's talk. Sir, the stage is yours.
Thank you so much for your very kind and very meaningful. Thank you so much for your introductions. That was really good, and this was. I'm so happy to be part of your team. Uh, Let me share my presentation first. Is it showing? Is it
I
visible?
mean, yes, it's visible. You can put it on full screen mode.
Is it okay now?
Yeah, it's perfect, sir.
All right, all right. Uh, Actually, today I'm going to take you to the journey of industrial safety. Okay, so it is very, very important. So, first of all, before coming to this point, thank you so much for the invitations that international faculty development programs. What I feel is that every one of us should know that industrial safety means when we talk about safety, it fits everywhere. Whether we talk about pharmaceutical, whether you talk about any organizations, so safety first, like whether in the traffic, whether in the constructions, wherever you talks about it. So safety is very, very much, and sustainability is very much important, because when invitation comes, then I saw that industry and sustainability in your frontier in bio innovations and innovations in engineering and biopharmaceutical for healthcare industry and sustainability. Then I thought that okay, this topic will fit and it will give enlightenment to the listener, and especially my dear faculty members, so that you should know that what is safety. Actually, all of us know that what is safety, but let's see that what are the new innovations and what we can bring up in our work culture over here, right, in our perspective uh, organizations. Okay, moving on it. Today our topics, as I said before, what are the innovation challenges and what are the impact. So in these presentations, I just take you to the journey actually, not in the very research orientations. I just want to make it more enlightenment, so that you should know that what are the innovations, what are the challenges, and what are the environmental impact happen in the industries as well as any organizations, right? So uh, as Somnight was telling that Mr. Roy was telling that I was the auditor. Yes, I was the auditor in a Cholamandalam actually. So there, some of the drawbacks are there actually. The past practice and the present practice and what could be the futures and all these things we have to know. So so many calamities happened. Not only we when we comes to talks about safety, everyone knows that fire and explosions only. But there are certain of things that we should know that contributes to the accident actually, right? So in these presentations I'll be talking about what the interactive part of uh, the concept of industrial safety, the current status in India, and what are some of the case studies, the classic examples of industrial safety, which is causation theory. When we talk about in this subject, we talk about causation theory. So we talk different type of scenario, that accidental scenario we talk about. So I'm just giving you some case study about it. Then why this safety and sustainability should work together. Then what is the difference between traditionals and the modern safety management? Then what are the challenges faced in the industries, and why we need to enhance or why we need to improve safety in our industries. Then what are the different type of frameworks that rule and regulations, SOPs and all. Then what is the cost benefits and employment engagements related with the safety culture. Then what could be the future trends. So these things, I'll take you to a journey. Slowly we'll just dive in and just see around, and you'll have that idea about it, what really I want to convey to you all, right? First thing first, as we all know that many people in India, we see that a jugaad system, right? Shortcuts we want, but we don't care about what safety much. Okay, like in shortcut, sometimes it clicks, sometimes it doesn't clicks, right? So in this photograph, we can see there's so much things that at a part of fire protections, in case of housekeeping, in case of machineries, we can see that like people are taking so much like about safety. So we should revisit our workspace, and we should know that like what are the things that we need to correct it, right? So in these pictorial diagrams, you can just see that like what is unsafe conditions and what is safe conditions, bad practice and a good practice. Here you can see that like mostly we neglect about, for example, the housekeeping. Sometimes where we don't care about the machineries, sometimes we never cares about the electrical safety and all. So all these contribute actually industrial safety. Okay, so things, we should think in the ways that like how not ourselves only but our environment should be safe. Okay, so that's why I always say that safety, environment, health, these three are always correlations. Actually, it's like a triangle. If the industry, the workspace is not safe, then it will impact to the environment. If the environment is not safe, whether it is polluted, then it will affect to your health. So no matter how much we talk about the technologies, no matter how much we do the research, but if your premises is not safe, then it is catastrophic damage. So once it is gone, it is very difficult to recommission it again. So we should always think that safety first. I think most of you maybe visited like pharmaceutical industries and all. So they are more into it environmental, health, as well as safety. So today I'll be more talking more on safety rather than environment, yeah, in health, right? So all of them are correlated. Okay. First thing first, in this particular, when we talk about safety, there are some terminologies we should know, like risk and hazards. Sometimes it is similar, actually. We use like both risky hai. Sometimes we talk, oh, very hazardous. But exactly what really it means, okay? These terminologies are very common. Sometimes when we talk about risk, sometimes it seems like that it means hazards, but it is not actually. Hazards, when we talk about, it is more the source of potential. It could damage your property, it could injure you, yeah, it can be I mean like financial losses could happen. Okay, so now we know that what exactly this source, it can be a physical, chemical, biological, ergonomics, yeah, electrical. Okay, fine. For example, if you see that like hazard could be fire, hazard could be I mean like due to the slippery you fall down. So these kind of things are hazards, right? Like not only toxic gas is releasing, there's also hazard is contributed as a hazards as a part of it. And hazards can be a numbers, fires, we talk explosions, all those things. They are hazards which can harm to the human body, yeah, damage the property. So this is what we call only when hazard does not cause harm until unless when you are exposed of it, right? So hazard and exposures that cause the potential illness or accident. Then we talk about risk. Sometimes we call it is very risky. What exactly this risk? Many people's like risk management. When we talk about risk management, we talk about financial management actually. But here in the safety perspective, we talk about risk is also a kind of hazards. Okay, so risk can be we talk in terms of probability, in terms of likelihood to occur. So it may injure, it may not be injured, but the probability, it is more about the reliability we talks about. Okay, there's a subject called reliability. There we always calculate that like how much probability is there. Okay, so when we map these hazards and risks, we can know that, like, for example, biological. When we talk about pharmaceutical, it's more of biological. Biological hazard, what is it? Actually, it can be a bacteria, it can be a virus, it can be a fungus. Okay. So ultimately, it will cause injury to, yeah, it will damage to, yeah, property, yeah, monetary loss and reputations, bad reputations. Of course, this can contribute to the risk. Okay. Now you know that like hazard risk very clearly, I hope. Then sometimes we just see the tips of the iceberg, okay, but we don't know beneath that how much is contribute, how big is dangerous there. So everyone knows that Titanic, right? So Titanic, it seems that like it is very beautiful, the scenery, the movie and all, but the main thing is that like behind that iceberg, how dangerous is it? So in industries also, many of us, we ignore unsafe act, unsafe conditions, near misses and all those things, right? we miss, all these contribute to the accident. Okay, so we should focus on hazard and risk so that it can prevent the future accident, right? Then safety we talks about. Everyone knows that the safety, like traffic safety, you should wear helmet and all those. Yes, it's safety, but really safety we talks about is a zero accident, right? Yeah, it's a zero danger. Okay, free from danger, injury, and all. Of course, that is the truth. But safety could be successful when everyone contributes, everyone take up as a responsibility. Okay, not only one person's, right? When we talk about occupational safety, it's more related with health, like OSHA. They say that like they are more into the worker safety, the persons who are working in industries. When we talk about top level to the ground level, okay, top management's people will be there, then after that the employee, then worker will be there, after worker the contractors are there. But here we talk about all of it, those people who are working in the organizations in that particular premises, right? So here our concern is more on health and well-being of the persons rather than property damage, yeah, any machinery damage. We are not talking about it in occupational health safety. So industrial safety, it comprises like practices like SOP, the rules, regulations, so equipment, so it can give overall. Okay, so workplace, if the workplace is safe enough, yeah, if that particular confined area is safe enough so that it can prevent from any accidents, injury, illness, and all, right? So ultimately, as I said before, if there's no safe, environmental impact will be there. If environmental impact is there, then it will ultimately it cause the health problem will be there. Okay, that's why and industrial safety is very very important. It's a pivotal, I should say. Then why it is very paramount it, because the reason is that like we need to protect a persons over there, the property, environment, productivity need to increase, and legal compliances. Why legal compliances? Because it can be penalized then if, for example, if your water which is discharged from that particular industry, from the hospital you talks about it, yeah, the waste, the solid waste you talks about, the air pollutions we talks about, if it doesn't comply, then what will do the pollution control board will come, it will penalize and it can shut down your particular organizations, right? Yeah, industry it can seal, so it can be penalized. So, yeah, so for that we need to have a particular, I mean like we need to have legal compliances we have. That's what we call act and the rules. Okay, that's also we're going to talk about in later slide. Then the next point is what are the key components? Okay, the elements are, for example, risk assessment, because many of us, yeah, we don't want to assess. Okay, it is very difficult. I mean, like it is very easy to finger point somebody false, but it is very difficult to point out our fault or our guilty, right? So identify the hazards and evaluate potential risks. This is very very important. Okay, and safe work procedures, the SOP, because in many organizations uh, they don't have proper SOP. Okay, like for example, if I come to your department, yeah, your institute, you may have different policies, right? So every industries are also having different policies in a sense like safety policy, environmental policies. Okay, why? Which based on what they uh, draw these they establish this policy based on these factory rules and all are there, right? That's also we're gonna just talks about it, okay, later on in the slide. Then personal protective, that is PPE, we talks about it. Everyone are familiar with PPE now because during COVID time everyone is wearing, I mean like sanitizations, gloves, all those things. So PPE is, everyone is aware of it now. Training is also the must, everyone should have trained. Now today also we have this is one kind of training, right? Faculty development program is also a kind of training. So like that, we need to have a training so that it is nothing like a olden days. That's why I said that like a traditional training or a modernized training. So that's also give you a high impact. The reason is that like uh, olden days people are more concentrated about related with in the aspect of safety. They're talking about when there's any accident, yeah, and an incident happen, they started doing the training. Okay, but in moderns, before such kind of mishap happened, we have to find it out, like we have to predict what kind of accident could take place, right? So in future what could be the accident could take place. So that's why we did a training. So modern and traditionals are totally, I mean, like different. Okay, that is also will come to when it slide we're going to talk about it. Emergency response and preparedness is very very important. Everyone knows that. Everyone is conducted a drill. I hope in your institute, yeah, in your organizations, you may be conducted a drill. Sometimes we call mock drills, fire drills. Okay, so this is very very important. Industrial safety could be bifurcated. Okay, like as a safety auditor, like when we inspect the industry, it is quite big from where we can start. The thing is that machinery safety, fire safety, electrical safety, we have to categorize. Okay, so all this comprises industrial safety. Okay, so industrial safety is nothing else as like a one point only, because it's a different type of dots. Okay, when you combine together, then it contributes to the industrial safety. Okay, whether in the form of machinery, chemical, well, whether in the housekeeping, whether electrical, so all these things comprises, right? So safety is everyone's responsibility. This is very very important. Now moving on to the next slide. What is the current status? Based on Ministry of Labor and Employment Government of India in their annual report, it says that 3 deaths per day, 11 injuries per day. I'm a little bit skeptical about it because yeah, injury 348, it talks about whether it is minor injury, yeah, it is a major injury. It doesn't mention, but it says injury. But I'm skeptical about because some of the small scale industry, they don't, I mean, like give a report. So maybe it may be increased also. Okay, so I'm just give you the glance about it so that like we'll come to know that like it is very very serious issue. Okay, safety is very very big issue. As I said, no matter how safe, how sophisticated equipments you are doing, how brilliant I mean like your equipment, your software, so everything. Okay, but if the place is not safe, then it's useless. That's what I would like to contribute on here, right? So in industrial accidents, what contribute the maximum? Like unsafe act, yeah, human error. Human error also very interesting. That like it you be a human error because he's not skillful, he's not knowledgeable. Yeah, due to he doesn't have a positive attitude. That's why this kind of error could take place. So human error also have a big topic actually. And unsafe act, unsafe conditions. This also matter a lot. Like when we talk about unsafe act, whether intentionally unintentionally you're doing the things, that's also a big subject actually. Then failure of equipments, a lack of trainings, then all these things contribute to a major accident, right? And government of India also now their initiative to frame an illegal, yeah, norms, yeah, standards, right? There are some campaign like uh, Surakshit Bharat and Saksham 4.0, yeah, Samridat Bharat, and all those things government of India also started doing. Then health safety and working conditions 2020 also they are coming up. So people are also working on more health and environment in a workplace. This is also very very important. Then why industrial safety matter a lot? Because it can protect human life, okay, productivity, economics, we talk about financial matter, then sustainability, of course, the compliances and all. So here, industrial safety, I should say this is like a tripod. Okay, it is like a people, process, and plant. They are all together. This is very, very important. The thing is that like this pillar, okay, the people may be competent, they may be awareness, training, knowledgeable, skillful. This matter, it contributes to the industrial safety. The process, when we talk about, it is more about like I said, like SOP, different type of SOP, the systems what we have, like safety systems, devices. You may be seeing that like fire extinguishers. Yeah, you may be having a fire hydrants. You have fire hose, smoke detector, fire alarms. All those kind of safety systems also comes under the process, right? Then the plan. What kind of plan? It is a engineering plan in the sense like when you design the reactor, when you design the pipelines, when the maintenance services, and what kind of technology you're using is outdated or not. So these all contribute to industrial safety. Okay, so sustainable industry, if you need, then it should be safe, efficient, and responsible. Okay, so way forward, we're gonna talk about like more advanced things, right? Like adopt advanced technology, AI, IoT, robotics, and all. We're gonna talk about so that it will give you more idea about like when you go to your respective places and all. Then you can just focus on what kind of working environment you are. What is it safe at present, or after listening to this lecture, you can motivate yourself and you can motivate your colleagues and all, so that they can also, more awareness should be given to them, so that you can live very safety. Okay, safely you can walk, like safety culture should be inculcated. When we talk about this industrial safety, there are four E's, very, very important. Four E's: engineering, education, enlistment, and enrollment, encouragement. Okay. So engineering, as everyone knows that, like engineering, design, and equipments and all implementations. Educations, as we all know that, like everyone needs to educate, awareness should be given, campaigns should be launched, enlistment, everyone needs to be participate, everyone should be committed on it. Encouragement, of course, everyone should behave in positively. Okay, and reward should be given to the person who are doing a good work. It should be acknowledged. Okay, they should be recognized, so award should be given to them. So all this contributes. Okay, these four E's is very, very important in industry. Okay, as I said before, just to give you a glance idea about it, like what are the frame and regulations we talked about. Okay, factory rules. Okay, factory rules and act. So it is very, very important. Suppose if I inspect one industry in Maharashtra, in West Bengal, in UP, so their factory rules will be different, because whether it is a earthquake prone area or not, yeah, what kind of nature calamities are there or not, so those factory rules are different as per the locations. Okay, as gas cylinder rules, whether everyone is having gas cylinder at house, right? Whether are you stacked in the proper format or not, there are some norms are there. Okay, so same as like environmental, OSHA, and the pipeline, industrial pipeline, and fire protection associations, which is related with any fire related. Okay, the industrial standards are there. Okay, like when we talk about quality management, so it's the ISO 9001. When it talks about health safety management systems, then it is talked about ISO 14001. Then it is more related with environment than ISO 14001. Okay, sorry, the previous one is 45001, right? Then ISO 14000 is more related with the environment. So not only this, there are electrical safety regulations, lockout, checkout, and work permit system, whether it's a hot work permit system, it is a cold work permit system or not, and there is an emergency preparedness and response or not. So there are certain type of things that like we have to know. Okay, like in the building. Okay, safety is as a general, like a safety, not only I'm talking about the industry now, it can be in the building, in the multi-storage building, wherever the corporate building also, safety audit inspections should be mandatory. Okay, so let's see that, like what kind of, like incidents takes place in the previous days. Okay, so I'll just show it to you, then it will give you idea about it. Okay, and there are certain type of theory. Okay, like causation theory we talks about, we are saying this is a causation theory. There are different type of causation theory, and one of the most popular, I should say, this is a Henry's theory actually. Okay, there's a domino theory effect we talks about it. So like these are dominoes. Okay, one falls to others, that it triggers to the one, to like that. But if we remove one of the dominoes, okay, then it will prevent, it will stop falling. Okay, so this is the Henry's dominoes theory. Okay, suppose before any accidents happen, yeah, before any injury takes place, if you remove one of the dominoes, okay, then it can prevent. So this is the theory. Okay, there are some bird theories are there. Okay, so in Hendrix he says that, like suppose 3000 people, okay, report there are unsafe, yeah, behavior, yeah, conditions, but people are not taking care of it, we are never noted, right? Because this unsafe act, unsafe, because in our organizations also sometimes we have quarrel, we have different mindsets we have, and sometimes people act very recklessly, yeah, unsafe act. So we never report. Okay, and we never try to rectify, then what will happen, it will accumulate. Okay, so this also very serious issue, we have to note it down. Okay, And near misses is sometimes in Hindi we call that bal bal bach gaya. Okay, so near misses also very very important. Of course, अभी आप नहीं बचा है तो बाद में आप नहीं बचोगे. So something like that. So if you are safe right now, you should inform. Otherwise, another third party, your second persons can be uh, he can have some it can be affected to him, right? So we have to report it. And minor injury, all these contribute. Okay, what if we are not rectified at the beginning, then slowly it will accumulate, then at the end what will happen? Fatality will happen, right? So injury, serious injury, and death could take place. So uh, as this theory says that like we have to mitigate, okay, whether at the starting point, yeah, at the middle point, before reaching to the tips, right? So this type of cautions of these accidents are mainly due to the communications gap, maybe lack of skills, unsafe act, unsafe conditions, change of management, yeah, management failure. So these are all related with the accidents. Like I just want to show you, like this is just simple data, just I want to give you the glimpse about it, that like how many people lost their life because of unsafe conditions and unsafe act, right? Like recently, if you see that like in Delhi Express also, there are 8 people were fatal, right? So that happened. If you see some of the cases like in the factories, I'm just compiling it. Okay, in the hospital also we can see, yeah, in the towers, in the shopping malls, in the institutions, coaching centers, yeah, anywhere. Not only industry. Just I'm just giving the glimpse idea. So mostly the maximum, if you see that fire, okay, fire broke out, so people this and this, so and so people died because more it contributes, whether it's a building, factories, hospitals, whether it can be a shopping malls also, okay, religious event center also, so everywhere. Okay, so fire because of what, electrical fault, short circuit, yeah, there are stack of combustible materials due to explosions, fire takes place. So this kind of damage happened, right? So when we think about all these things, are we still skeptical about it or not? Yeah, we should take a corrective measure or not? Are we still happy with our, comfort zone? We should come out and we should focus on safety, right? This is very very important because all of us knows that like my building is safe. If you suppose if you go to any corporate building, okay, you can see that like it looks very beautiful, like beautification is good, cosmetic beauty is there. But if you go inside, okay, then there are lots of electricals, wires, cablings are there, okay, like AC duct and all. So they are very, very harmful actually. Harmful in the sense like what kind of electric cables they're using, any fire retardants are there or not, any safety devices, okay, safety systems is there or not, whether it's functional or not. So all these things we need to taking care of it. Suppose I'm just giving you some glance about it, like see, you can just see that like just I'm just giving you the glance about it. Okay, in the rubber in Delhi, okay, in 2019, there is rubber factory. Okay, so 3 people died. Okay, usually whenever these things happen due to the electrical short circuit, the electrical failures, yeah, poor housekeeping. Okay, but the thing is that like, are we really serious about safety or not? Are we really awareness about safety or not? This is the very very big questions. Okay, like not only in the factories, it can happen in the oil company pipeline. Explosions takes place. Okay, so here recently, I want to show you recently in the Lucknow. Okay, so recently I think it's hardly uh 2 weeks back, right? So it's in June 22, right? Last month. Yeah, it was in the last month. So what happened is that this is not industry, but I just want to give you the idea about it. When this kind of catastrophic damage happened, what, we lost our family members, right? Innocent people. So what lagging behind? Okay. So are we, all of us, aware during this time of calamities, this time of disaster, difficult times? So are we really trained what kind of actions we could take when this kind of emergency things happened? Most of us are in trauma. Okay, suppose right now you may be sitting in your respective area, suddenly some bomb blast happened, yeah, something, a fire breaks out, you'll get panic. Then you won't know then like what's going on. You may be shouting, you may be jumping here and there. So we need to have a proper train because everyone has different psychology mentality we have, right? So some people are very sensitive. Okay, so we need to train them like this kind of situation comes, then what kind of step we have to take. Okay, nowadays, I mean, like the world is not that good. War happens suddenly, some bomb blasts happen, sometimes some natural calamities happen, earthquake happen. Are we going to be panic and stay in one place? Yeah, we have to move. One, what kind of step we have to take? This is very very much important actually. Okay, so you may be thinking that like the world will be like this. No, if we are progressing, the danger also more. So we need to know that like how to tackle this kind of situation in this kind of situations, right? Just a classic example. I just want to know. Everyone knows that like Bhopal tragedy. Everyone talks about Bhopal tragedy. My really question is that is there is any safety system during that time? Okay, so many people died. We know that like more than 2000s people died, right? Some injuries happened. Everyone knows the story behind of it, right? ISO, uh, cyanide, MIC, that leakage. Okay, like it is something like the vice president says that like it's like a blaming game. Okay, the people, the worker who died there, they said that family people, they said that they don't have any proper safety systems. They don't have, of course, this is also a very, I mean, like, we have to think about it, whether they have, it's a very genuine point, right? Whether they have safety systems or not. But the vice president's Brown injection says that no, this is because of the persons who were walking there. He was angry. Yeah, he was not happy. That's why he put intentionally water in the MIC storage. So what happened then exothermic reactions takes place and reaction takes place, then the valve pops out, right? Then once it pops out, then it is out of control. Then what will happen? That the gas leaks and it reaches to the throughout all the premises. Then it goes to the villages nearby, right? That is how people die. Okay, I'm just giving a shortcut, the story about it, right? But my concern is not their story. My concern is safety system. All right. So I'll just give you the idea about it. Of course, they have safety system during that time. Many of us thinks that like they don't have safety systems. No, they have safety systems. But the problem during that time is that uh, whether it is working properly or not, whether it's a functional or not, yeah, this kind of accidents, whether it can cope up or not, that is another issue again. Okay, being a safety engineers, yeah, safety audit. So we have to think that like what really goes wrong. Number one, is it safety systems are there or not? If it's there, why it is not working? Okay, so that is the concern. Okay, so in this classic case study, we can see that first of all, like they have a process hazard analysis operation procedures, they do have. But the problem is during that times the review was going on, okay, in place. They're trying to commissions, okay, recommission. Yeah, they want to install new, okay, stack. So during that time it was not working. The vent gas scrubber, okay, vent gas scrubber is usually when the toxic gases are moved out from that particular container, then it will move up to the vent gas scrubber. There they are suppressed by spraying, okay, they are suppressed by neutralizing, like caustic soda, they spray on it so it neutralizes the toxic chemicals, right? Then it went out on top of it, but the height was so high because during that time it was not commissioning, it was not working conditions, right? That is another fault. Work permit systems, if you don't have work permit system, then anyone can enter and do whatever they want, right? But you need to have a proper work permit systems. For example, if there are contractor are coming, they want to repair, they want to do the welding. So the person who are in charge in that particular area, whether he has to check that, like he has to give in the permissions to work there or not. Until unless if there is no work permission is not there, then a person cannot enter there. Okay, the competent person has to work there. So during that time, it was also not working. Another thing is that emergency plan response, because whenever this is a curtained water curtain, how it works, because if there are some gases are released, then water curtain should splash and it should suppress, neutralize all the toxic chemical. It's somewhat is very similar with the vein gas scrubber. Vein gas scrubber, they use the caustic soda. Here it gives just a water spray, right? It is something like in the highway, during summer times when we go there, like some water tanker they spread in Delhi and all. If you can see that, like they spread water, because not for cooling only, but it can suppress the dust particle also, right? So same as like in industry also they have, but during that time, it could goes up to 12 to 15 meter only, but the gas released 33 meter height above the ground, okay, above the ground level. So it could not reach. So this is also a big failure. Mechanical integrities, but mechanical integrity, when we talk about the have a flare systems, whenever toxic, if you go to any chemical industry, okay, like gas industry, yeah, oil industry, they you can see that some flare is going on top of it. Here, those unwanted gases are they burn it off, okay. So in simple terms, I'm just giving you. So here also during that time it was not working. Then another change of management. When we talk about change of management in our house, we have inverter, no, when the light cuts, then we have an inverter, okay. Same as like when this tank, okay, this MIC storage tank. So if the MIC storage tank is becoming exothermic reactions, then it will heat up, okay, then it will build pressure. Once it build pressures, then it is very difficult to control. Then the vent pipes would be there, like something like a spring valve, the valves, safety valves, but the safety valve was pops out, so out is out of control, okay. So when it becomes very hot, you need to cool it down, so you need to have some backup system, right, so that it will cool down. But during the times it was not there, okay, it was not cooling down. So these are some of the safety, okay, things they have, but the thing is that at that time it was not working. So mainly the thing is that like one though we can see that after this tragic, one is unsafe and unsafe conditions, one is personal and job factors. Okay. So of course the industry and the people working over there or the blaming game is always there. But anyways, but the basic as an engineers and as a researchers, when we look about it, so proper emergency response should be there. Evacuation systems was not there, okay, so that if evacuation system is there, then all the villagers could evacuate at the times, okay, no casualty could happen, right? So these kind of conditions, okay, so these classic examples teach us process safety management is required, okay, standard SOP is very much required, and human error is also applicable. So everyone needs to be trained and everyone needs to educate. This is very, very important. Moving on to that, why safety and sustainability should go along, okay, why together? They share the same goal actually, okay. Like for example, it can protect the environment, like when we talk about environment, whether it's wastewater or pollutions, in terms of solid waste, in terms of gases, in terms of water, right? So environment, okay, efficiency, okay, then compliance, we talked about the growth, sustainability growth, of course. Once if you have proper efficiency, then sustainable growth will be automatically, it will happen. Integrated management, when we talk about management systems, maybe it can be safety, environment and equality management. That's what earlier we talked about ISO, okay, ISO 9000, 9001, 14001, 45001, all this management, okay, they should be integrated, right? Then synergies, we talked about what are the key synergies. Of course, economical benefits, reputation and trust is very, very important. People should always be the first priority, okay. Then we can talk about enablers for success. Of course, everyone has to be strong leadership is required, commitment is required, technology updation is very much required. So everyone should be, included. Okay. Bottom line, I should say that like sustainability without safety is unsustainable. That is what's my point. Then together we can build, stronger and more safer and sustainable for futures. Okay. Traditional and modern safety. See, both of them are safety management. Now, still people are practicing these traditional also, and now it's a transition period. So I'm like people slowly shifted to the modern safety management also. Okay, just like I just want to highlight some of the points, like the approach, the focus, okay, the training, the goals, everything is the change. For example, just let's see the approach. Okay, the approach is more proactive in the modern. Then if you see the traditional one, it is more reactive approach. After accident occurs, people started responding. Okay. But in modern, before things happen, how can we prevent, yeah, protect, okay, the accident before it happens? This is the modern, that is their motto actually. The focus is similar, but the thing is that they are more focused on investigation in incidents in the traditional one. But in the modern, it focuses more on identifying and controlling the risk. Then one very interesting part is here, the tools, what we are using the tools. The earlier days, we used the manual, okay? Inspections, manual karte hai, and paperwork. But nowadays, we are using AI technology, sensors we have, real-time monitoring systems we have. So these people are a little bit, like, as I said, transition period, the people are started working on it. Then the action, if you see that like a predictions, okay? In a modern, we predict, then we mitigate, okay? But earlier did corrective actions after failures. So I mean, like if you just compare these two together, then you'll know that like the real picture, okay? The real pictures, why we need to improve a lot. So we have to do lots of homework on this, right? The current issue, the challenges, okay? We have different type of challenges we have, but I'm just pointing out only three, okay? Which is very genuine. Okay, the current challenges, yeah, the issues, the problems, what we have is the lack of training, inadequate training and protocols. As I said, like every organization have their own protocols, but when you don't have protocols, it is very difficult to control. In a sense, like if some new joinee comes and if you don't have protocols, then what kind of rules, what are the procedure he can follow? In office also we have a big problems, right? So we need to have a proper protocols. Insufficient risk assessment. When we talk about hazard identification, there are certain tools. Here, I'll just give you the glance about it, but we did the research on like HAJOP, LOPA, fault tree analysis, event tree analysis, and all. So there, these are the tools of hazard identifications. Okay, so risk mitigation process, sometimes we overlook of it. Whether it's a quantitative analysis, whether it's a qualitative analysis, okay, quantitative analysis, we should not ignore about it, right? So whether this risk assessment is very important. Maybe quarterly will do, yeah, weekly, monthly, it depends on the scenario. Okay, then uh, equipments, this is very important, because as you know the technologies upgradations there, everyone is using mobile and all, but every 2 3 months it keep on upgrading, something like that. In industries also, their equipment sometimes it's outdated actually. Okay, so all missionaries, people are thinking they're like why should I invest more money on it? Yeah, lack of modern technologies, become chala rahe to I'll use on it. So this kind of mentally if we have, then I mean like it will give you a very big challenges. Okay, so if you really want to build safer and more productive industry, you should be focused. Okay, not only on technology but also assessment also. That's why I just call it this, like whether it is hardware, whether it is a software, whether it is a humanware. Okay, so these three is very important: hardware, software, and humanware. Sometimes we call it lifeware also. Okay, to improve, to enhance, okay, safety system, Okay, safety in industry. This is the latest and the modern safety systems. Okay, I'm not talking about the olden days, because olden days we have lots of documentations and all, but right now we are more focusing on safety in industry by using this kind of technology. For example, automation systems, data analysis, wearable tech, drone systems, we have AI system, and training. Training also not and just like a lecture type of training. Okay, it's more about the real world kind of like VR, AR, virtual reality and all. So those kind of training is required now. Okay, because technology empower people, prevent accidents, and build a safer, smarter industry. Okay. For example, automations, just give you a glance about it. Automation and robotics, because if the problem is a person is walking in a very risky area, okay, but the solution is just implement the robotics, okay, then it can solve your problems. Plus, it will reduce your cost, the time, and can reduce the accident rate also. So mostly it will give you a protections for the worker. Okay, so improve efficiency, of course. Then data analysis also, most of our data analysis we are using manually and all, but now the AI is coming up, so people are started implementing. So incident injury rate is becoming low, near misses people are addressing now, so it will become low. Okay, compliance rate is increasing, training completions, people are more interested to take up the training and all. So skilled workers are more now. Okay, so this will continue the safety. Okay, and it will predict better. Okay, then wearable technologies is also very very common nowadays, because smartphones, everyone is having that smart watch also, people are having. So people are using this kind of small devices. Suppose if you want to track somebody who are walking in a risky area, and you want to see that his heart rate, whether he's alive or what is the medical conditions. So by monitoring his like wearable technologies, we can monitor what the status, okay, whether he's working properly or not, we can track it. Okay, performance analysis we can do, alarm systems it can provide. So the benefit is their health monitoring, fast response, and the risk reductions. And drone, it is very very crucial, I should say, because there are certain of places where people could not reach. Okay, for examples, like if you have a high rise building, yeah, if you have some chimney, some leakage happen, yeah, some crack happen in the pipeline, in the chimney area, or in the reactor, in the storage tank. So it is very difficult to go and inspect there. So the solutions, what the engineers, the safety engineers propose is that are the drone systems. If we can use, if we can capture high resolutions image and videos, then we could analyze it. Then we can take the corrective measures. Okay. So inspections will be very fast. Okay, and very efficient, time saving, and cost effective as well as, and better monitoring. Okay, so that like overview we can monitor. Okay, so drone systems also started, people are working on it. So these also new innovations in the aspect of industrial safety. IoT, okay, Internet of Things and smart sensor. So these also people, of course, earlier days they have devices and all. Now people are more into with implementing the sensor as well, like environment, temperature sensor, gas sensor, like yeah, hydrogen generations and all. It is very flammable, so people are having some gas detector, yeah, sensor they're implementing. Okay, real time monitorings people are doing now. And yeah, this is virtual, augmented, and reality. Okay, this also like a training, it's a tools for the training actually, simulations like flight simulations for the pilot and also industry also. Now if you are really interested, you can attend the training, because there are certain organizations they are having this kind of training. Okay, so virtual training, there's something like a simulation. Okay, so they have some simulator they have in the room, and you'll go in a risky area. But the interesting part is that like physically you're not harming. Okay, you'll be protected. I mean, like it's just only virtual only, but the real world activities you can experience of it. Same as like AR also. Okay, so like the pressure is high, then if you can lower it down. If the temperature is high, you have to uh, whether increase or decrease, all those things, monitorings. Okay, I'm just giving you some ideas about it. Okay, so this kind of virtual, simulated kind of a training excel actually. People are more interested, and rather than giving lectures on it, people are more into with the practical things and all, right? So this kind of training is very very much important in any organization, I should say, not only in industry, like in education also, it is also very much required. Regulatory framework surrounding safety technologies. Okay, just as I said already, that like regulatory things is very much important, whether uh, documentations, why it is important, because if you are going for ISO 6 sigma certifications and all those things, so documentation is very much important. Training, of course, we talk about audit is very important. Audit your inspection, okay, whether it is an external audit, internal audit. Okay, so you need to have audit, whether in your institute, in your department, in your office, you need to have an audit, because it's not matter of financial, but it's a matter of safety, that like whether are you sitting in the safe zone or not. Okay, so you may be sitting in a confined area where some uh, safety is very low. Okay, for example, like when we inspect there, we check. Okay, for example, like a national building code, according to national building code, how many fire extinguishers has to be installed. Okay, then what kind of standards we have to implement on it. For example, like whether it is required, smoke detectors should be implemented or not, sprinkle systems should be there or not. So those kind of things, okay, the auditor will tell you, okay, by quoting the standard. So there is a one very controversial is that like if because safety system is very costly again, so it is not necessary that like you have to purchase all the safety systems. Okay, there is a one question mark there, like I should for safety I should purchase all like smoke detector, fire detector, fire alarms, all those things. But as per the national building code, whether it is required or not, we have to see as per the standard actually. Okay, because it's costly, it's expensive, so you need to optimize it, whether it is required or not. As per the rules, we have to know, okay, whether we have to implement or not. Yeah, as I said, like safety innovations, of course, when we talk about the benefit is more weightage than the cost. So many people are thinking that like I should concentrate in more in the production line rather than safety. Okay, I said it is equally important, safety also, production line also, both, it should go together, balance. And if you see that like the benefits, higher productivity, you can get more insurance. Okay, rather than like many people pay high insurance for one equipments and all, like. So if you put more safety system in your premises, in your organizations, okay, then insurance is not required. I don't say that it's a zero, but the premium can be much lesser. Okay, then improve reputations, of course. Suppose if you have a very bad safety systems, then something will some what do you call, mishap could happen. Okay, some fire could take place, then of course your reputations will go down. So I mean, like, these are some of the generic terms that like we should know. Okay, then like are we really go for safety or not? Okay, so it's depend on the persons, then it depend on the organizations, whether they should invest money on safety more or not. So according to that, you cannot directly tell. So you need to have an expert, auditor. Okay, once it will inspect, then according to that, you have to invest the money. Okay, but it's worth it, I should say. Like if you upgrade, if you do training and all, of course, it takes lots of revenue. Okay, training, conduction, upgrade of technology. So revenue plays a lot actually. So that's why I mean, like, there is a controversial that like are we really need that or not? I have been working here more than 20 years, nothing happened. So I don't think so it will not happen again. So people, when we interact with industrial people and all, so that is what they used to ask. Okay, but it is very risky, I should say, that like you should not avoid. But if you not avoid also, this is I mean, like I just leave it to your wisdom. Okay. Employee engagement and safety culture. Of course, safety cultures always give a positive vibe, yeah, environment, right? So communications, participations, recognitions, training, and leaderships. So if there are always negative, and if there are, we know that the politics is everywhere, right? But you need to have inculcate that like safety culture, so that people will be motivated. Okay. And in any scenario, okay, emergency scenario, what kind of step you have to take up. Okay. So safety culture is very much important. Okay. Whether you're from, I mean, like big organizations, yeah, small organization, it doesn't matter. Okay. You need to inculcate this, yeah, adopt in your organization. Future trend in industrial safety technology. Okay. So AI technology, we talks about it. Wearable technology, now IoT, internet connections, we talks about it. The green technologies and digital. So these are the current trends, and things are started implementing, and still not yet implementing in India also. So people are started aware of it. Just people are started coming of it. So lastly, but not the least, in my conclusions, I would like to say that like a sustainable industry safety is very, very important. Everyone should have a knowledge about it. Okay, innovations, technologies, upgradations, what are the latest things going on? So everyone should know it actually. Okay, and as we ongoing research and technologies and all, so we uh, should not stop in doing research, continue research on it, so that like it will give you more better, safer, okay, transformations would be there. Okay, and it will provide safer, more efficient, cost effective solutions for the futures. Okay, then the lastly, the things that like collaboration work. Okay, alone you cannot do, but you have to collaborate with the industries, government, academic institutions, and international organizations, so that it will enhance, okay, our this kind of sustainability, actually safety sustainability, right? So government of India also, it proposed like Viksit Bharat, right? Viksit Bharat, the main motto is to transform India into developed, self-reliant, and inclusive nations by 2047, right? There it talks about sustainable economic growth, equality, right? Social equality, technology advancement, environment protections, and improve quality of life for all citizens. So here it includes the like as we talks about, when we talks about technology advancement and environment protections, what you need to be, I mean, like move in the technology that like before modern safety management, rather than the olden, yeah, traditional safety methods, right? So here I would like to motivate each one of you that like be strong in safety culture. Please inculcate a safety culture in every field where you are, right? So lastly, I would like to say that like every one of you may be a teacher. Okay, so Dr. APJ Abdul Kalam, he quotes that like great teachers emanate out in knowledge, patience, and compassion. So are you a great teachers or not? You have to evaluate yourself, right? So thank you so much for your kind attentions, and uh, lastly, I would like to encourage you that like think safely, act, think safety, act safely, and be safe, right? So that like your health, your life is very, very precious. Okay, so thank you so much. So if any discussions, if you want to make, then I'm feel free. Yeah. Hello.
Yeah, thank you, sir. Thank you for this wonderful presentation and making us feel the importance of safety in our lives. So I now open the session for discussion. People can post your queries, questions on the chat box, or you can just raise your hand. We can unmute you and you can follow up. Let me quickly check the chat box. So there are lots of appreciation notes. Thank you once again, sir, but I don't see any questions coming out. So audience, please feel free to ask questions to Professor Swantak regarding the importance of safety in different aspects of our lives. Uh, I guess there are no questions in general. Okay, then I guess we are almost to finish today's session. Thank you once again. sir, for a wonderful lecture. So please join me virtually to present the token of appreciation, the memento, the e-memento. So I quickly share my screen. Thank you, sir. Thank you for uh, accepting our invitation and for your wonderful talk for this International Faculty Development Program Frontiers in Bioinnovation. Thank you once again on behalf of organizing committee. And I do see our HOD, Dr. Gaurav Kumar on board. So I now hand over the charge to Professor Kumar.
Thank you. Thank you.
Yes, sir.
Thank you, Somnath sir. Actually, I would like to thank Dr. Saurav Yadav sir, who has connected to such an esteemed professor, Swantak sir, with us. And sir, we are really honored to have you in this international FDP program. And on behalf of our Department of Biotechnology and Bioengineering and School of Bioscience and Technology, with our collaborator, University of Cyber Jaya, Malaysia, I am honored to offer you this digital memento. So kindly accept it, sir. Uh,
Thank you so much, sir.
okay, thank you so much, sir.
Thank you for inviting me, and it's a great privilege to be here, be part of your team, sir. Thank you so much, sir.
Thank you so much. So, dear participant, we have posted the feedback form link in the chat box. So please fill out the feedback form, as your feedback is really valuable for us. Thank you everyone for joining. Now over to you, sir. Somnath sir.
Okay, so we are almost done with our penultimate day of the faculty development program. We had wonderful sessions. So tomorrow we are going to have the last day. So I request all of you to maintain this pace, and we will be seeing you, all the participants on board tomorrow, same time. You can use the same link for joining, and we are having another lined up wonderful speakers, insightful talks on the last day of this faculty development program. So with this, we can conclude this today's session, and I wish you all a very good evening, and stay tuned, stay with us, and let's finish this wonderful faculty development program in tomorrow's session. So goodbye all, and see you tomorrow.
Sir, please transfer the host to me.
Yes, sir. I'm
Okay.
just doing it.